And here we go. We have liftoff. Propulsion continues to be nominal.
R68 chamber pressure looks good.
Traveling up. Roger, with planet.
Water towers fly! Yes!
Tango down to nominal.
Flight downside at speed off. Bring in at speed off. It's orange!
Orange 45. Oh my god! Oh my god!
Decollage. Put that in the big bag, Eagle.
343 unfolds to go.
Indeed.
We rise together back to the moon and beyond.
Flare, correct?
We don't need any more of these.
Welcome, everybody, to another live launch coverage from NSF, live from Starbase, Texas. And on your screen, you see the full stack on the launch pad. We are bringing you live launch coverage here at NASASpaceflight.com and also on the Popular Science Channel. Welcome in. I'm Gene Rowley for NSF, joined by EJ.
What's going on, everybody?
We are going to bring you live coverage from our cameras in the field and all of our great cameramen and commentators around Starbase. And boy, we have been looking at an amazing rocket for the last couple of days. But today, the fog decided to roll in, so we can't see much here, but that's okay. We know there's a rocket out there, and it's getting ready to launch. We're going to bring you up with an update with what has been going on the last couple of days and where we currently stand. EJ?
So basically, the weather has been pretty dang clear all the way up until this point. It was actually beautiful yesterday, Gene. We had perfectly clear skies. You could see for miles, but that doesn't seem to be what's going on today. But somewhere out there in the fog behind us, we have Booster 15 and Ship 34 stacked on top of each other, ready to go. Supposedly. We'll see what happens. They are watching the winds a little bit from what we heard from Adam Suker in the Starbase stakeout streams. They're watching the winds a little bit. We also heard a couple of people from SpaceX commentate about that on X. The wind is kind of a thing, but got to remember that just because we have low visibility and we can't see the rocket doesn't necessarily mean that the rocket won't launch. I mean, that would be not cool if we did. We wouldn't be able to see it, but it's still, that doesn't mean it's not going to go today. But we're kind of sitting here with bated breath, hoping that we do see some action today.
Yeah, and we'll be checking the weather. We'll bring Adam Suker in. We're going to check some maps. We're going to check all the aviation, all the NOTAMs, the notice to air missions, and the NOTMARS, which have to do with the sea vessels that go out from the coast here. I want to bring in another one of our commentators. So if you're on YouTube and you want to leave us a question, you want to send that in, you can do that at NASASpaceflight, and that will go to the one and only Adrian. Let's bring Adrian in, and he's going to be the one asking the questions of our commentators. Adrian?
Hello, everybody. Glad to be here for one other Starship flight again. I'm so excited. Of course, fully agreeing here with EJ. It would be great if we get like this perfect condition miracle, and suddenly it clears up, and we maybe get like this perfect window. There's some hope for that. I can already spoil that a bit. But yeah, I mean, of course, it's still a Starship launch, so we are absolutely excited. I'm looking forward to all the questions we will receive over the next, well, 3 hours or so.
Yep. And all through the morning on YouTube, we've had what we call our stakeout. We've had several of our commentators in the field, our photographers answering questions. And one of the people that we love to have on stakeout is Alejandro Alcantarilla Romera. His name is Alex around here, and he is one of the smartest people we know about rocketry and spaceflight. So let's bring Alex in. Alex, how are you today?
I'm doing fantastic. I cannot wait to see another Starship launch, of course. We are less than 3 hours away from that. Tank farm spooling up, fog rolling in, unfortunately, but, we'll cross our fingers and see if we can see the rocket and get that liftoff in 2 hours and 55 minutes from now.
And we'll see what happens with this one, because Flight 7 launched on a beautiful day. We saw it go up. We saw Booster 14 turn around after stage separation and come back to the launch site here at Starbase, which is just over our shoulder on the other side of the fog. And it made an amazing catch with the chopsticks. What you see on your screen right now is that upper stage, which is Ship 34, and it's stacked on Booster 15. So We might be able to see that today. Our cameras here at the hotel are a little fogged in, but our close-up cameras are absolutely amazing. We're going to bring you those views. Now, Flight 7 ended with a rapid unscheduled disassembly, and it was autonomously. The flight termination system was activated, so that worked as expected. And if you are a space flight enthusiast, you probably saw the pictures of it coming into the atmosphere. It was a pretty dramatic re-entry over Turks and Caicos. We're hoping this one goes well. They made some changes to the ship, EJ. And why don't you talk us through some of the changes they made from the previous flight to this flight?
So, well, there's always a bunch of different hardware changes with Starship. They always change something because of the rapid iteration that SpaceX does. There's always going to be something that's a little bit changed around. Now, this flight, like Flight 7, is a Block 2 Starship. That is the biggest change. So what that really nice rainbow of debris that we saw over the Turks and Caicos from Flight 7 was basically the ship exploding. And what happened was that there was a fire basically on board that they couldn't contain anymore. And that happened basically, I mean, the plain English way of saying it is that the fuel lines were shaking and they broke. The real nerd way of saying that is a harmonic resonance was induced on the vehicle during the ascent. And it caused a rupture of the fuel lines that could not be contained in the aft section of the Starship. Yeah, see, that was pretty good, right? So the fuel lines basically shook themselves to pieces and it caught the whole thing on fire. And rockets really don't like being on fire anywhere except inside of the engine. If you get a fire outside of the engine, it doesn't really end too well. So what SpaceX did was the ship that we currently see out on the pad right now is ship 34. They did put 34 on their test stand at the old NASA's gun range, which is where SpaceX does all their testing now. They put that vehicle out on the test stand for a 60-second duration burn. And during this burn, they were modulating thrusts on the engines, up and down, left, right, maybe to the side a little bit. Who knows? You got to get that side fumbling down, right? They were testing different thrust regimes here on that to try the same harmonic resonance that was encountered on Flight 7. And well, let's be real. They wouldn't have stacked that thing and put it out there if they didn't find something that they were like, oh, okay, we can fix that and mitigate the problem. So I'm not 100% sure what that mitigation entirely is, but well, we know that, like I said, they wouldn't be putting it out there if they didn't have a fix for it. Now, there's many ways to fix that problem. You could just redesign the pipe, like, oh, just redesign the pipe. No big deal, right? That's no problem. I mean, it isn't seemingly with SpaceX, which is pretty cool. I mean, that's all why we're here, because they're just like, oh, yeah, we can fix that. No problem. But it could be just, not operating the engine at a certain throttle to cause that type of harmonic resonance. Basically, it's shaking too much. Rockets shake a lot. They do. I mean,
it is a thing.
Yeah, it's definitely a thing. So basically, they found some type of mitigation through that static fire, and that's why we're here today. That's why we're getting ready to go, hopefully. I mean, we just want this cloud cover to go away so we can see it.
Yeah. And initially, SpaceX did tell us that they had put some more vents in to the skirt, the bottom part that covers the engines. They also added some nitrogen purge above the attic. And when we start talking about venting and nitrogen, and it gets kind of scientific, this is where we always bring in Alex, because Alex follows the stuff like nobody that I know, and he gives you the best answers. So when we talk about a nitrogen purge, we're actually talking about fire suppressant, right, Alex, inside the rocket itself, where the fire shouldn't be.
Yeah, they probably carry their own nitrogen bottles for that. They have multiple what they are called COPVs, aka composite overwrapped pressure vessels, essentially like aluminum cans at high pressures that are wrapped with carbon composites, right? And they carry many of those on the ship and also on the booster. And they might dedicate some of those to storing that nitrogen, and then you essentially flush all of that nitrogen into that cavity between the engine shield and the aft dome of the ship, and then that's the portion of the vehicle that they call the attic, right? So you flush all of that, and then they have vents. They have also added more vents, because that's one of the things as well that they found out, that that fire that was started, it was too fast and too powerful essentially to be put out by venting it out, essentially, because you are in a vacuum, so you can just put it out by letting everything escape to the vacuum and not have that source of the fire in the first place. But unfortunately, just with the harmonic oscillations, that ship was of course doomed anyways. But if it were to happen in the future, knock on wood it doesn't, but if it were to happen, at least they have reinforced that area with that prevent sort of remedy, so to speak, right? That will be able to put out those fires. Yeah.
So on your screen right now, on the right-hand side, you do see a ship stacked on what we call Tower 1 on OLM or Pad A, Tower 1, and beneath that you see the just the top of the booster. On the left-hand side of your screen, you see a helicopter, and it looks very reminiscent of a Coast Guard helicopter. It's painted the same, but it's not. EJ, what do they do with that helicopter? Is that clearing the water around? What's that helicopter for?
Yeah, basically that helicopter, from what I understand, is perimeter security. It looks like a coastie helicopter, but it's not. It's a private helicopter, and SpaceX contracts out that service to go and make sure that nobody's near this thing. I don't know if you guys realize this is the most powerful rocket humanity has ever flown. We're talking about 15 million pounds of thrust at liftoff. That's like 70 meganewtons for the metric folks. That you don't want to be near that when it goes off. Yeah, you don't want to be near that. So what that helicopter is doing, it's actually refueling right now, and but it's been going around patrolling the perimeter to make sure nobody is near this thing when it goes off, because you can get right up to this Starship, not when there's a roadblock. When there's a roadblock, that's why the helicopter is there. But during non-launch operations days, you can get right up next to this thing. It's actually one of the cooler things about Starbase. You can get right next to it. You can go right up to it. There are fences and stuff, and there's obviously signs that you should read where you shouldn't go there if they say don't go there. But it is a very much Highway 4. The road that the launch pad is actually on is a very public road. You can go right up to this thing, within reason. Don't make the sheriffs in Texas angry. That would be a big mistake, right? But you absolutely can go up there. So they're sweeping the perimeter and making sure there's nobody around. You don't want to be near this thing when it goes off.
Yeah. And if you were watching the stakeout earlier today, we just talked a little bit about the roadblocks and where they are. And they start pretty early in the morning. They start with a soft roadblock, the Cameron County sheriffs and some of the SpaceX security folks. They start with a soft roadblock, and then they clear the beach and ask people to take their last photos and kind of move everybody out. This is a very, very powerful rocket that we see on the OLM. And again, on the right-hand side of your screen, there's one of those roadblocks where eventually that roadblock will actually get pushed farther back away from the rocket before it starts fueling, and then it eventually lifts off in just under 3 hours from now. We're at T-minus 2 hours and 47 minutes. And I'm going to take this time to just kind of tell everybody who we are, right? If this is your first time watching a rocket launch or a Starship launch, we're NSF. We're NASASpaceflight.com. We have cameras and remote cameras all over the Space Coast. We have them all over Starbase, and we have a very large team of people who just love rockets. We might look it and sound like it sometimes, but we're just a group of friends that really, really enjoy rocket launches, and we're able to do this. It's a privilege for us to do this, to bring it to you. And we love the fact that you're joining us for these launches and support us in doing so. And so one of the ways that you do that is you hit the thumbs up button on YouTube, and you can also, go to our store and all that other stuff. But there are so many people that we want to thank. That's Adrian's job during these launches. So I'm going to go to Adrian because I know for a fact he gets behind. So Adrian, let's take this time to thank some folks who are supporting us.
Absolutely. I have quite a few already, and as you said, I'm already behind. Let's start with Maharnar with a super chat here asking, what is the airspeed velocity of an unloaded swallow? Love you all at NSF.
African or European?
Not clarified in the super chat. Also, we have Conservative Space Nerd with a $100 super chat saying, hey guys, been a while since I contributed. Thanks for documenting this new space race literally from the ground up. And also apparently from a few more altitude higher, because I think you're like in the 12th floor right now or something. So it's a bit higher up. We have Nick here with a storm message saying, just received my Flight 7 patch and pre-ordering this Flight 8 Have all 7 so far. Thanks for all the great coverage. Go Starship. That's an amazing collection. Thanks for supporting us all the way to now 8 patches. That's really, really cool, honestly. Then, oh god, we have really, you don't say, with a super chat saying, wow, sight fumbling. You think they would have calibrated their X encapsulator?
Well, the hydrocoptic nozzle vanes need to be in perfect alignment to be in line with the pentametric fan, Adrian. So give it some time.
Sorry.
Yep. No,
I'm giving.
Yeah.
Ruin Viser here with a super chat saying, I just got back from Iraq. I'm super excited to get down here for a launch. And after launch, a party at the Margaritaville? Question mark. We'll leave
Can
that.
I jump in here and just say yes? One veteran to another. Thank you for your service. After this launch, come find me.
There you go. So that's, I think, let me end this with a question here. Because there's a wondering here about the materials that Starship uses, which right now is, of course, stainless steel. And Toy Story here is wondering, do you think new and lighter materials instead of steel will be eventually used for Starship? 10 or so refueling missions to send Starship to the Moon and Mars seems a lot. And with that, I'm caught up here.
Alex, what do you think about that question? It's a great question.
Yeah, I knew it was going to be sent to me. I unmuted the moment I heard materials. The whole deal with 10 or so refueling trips, it doesn't have to do with the material. It has to do with the physics of the problem. You launch a ship that is basically empty compared to how much propellant it can carry. Like, if you were to carry an empty ship and we go by the referenced, 100 tons to low Earth orbit, which there's some debate whether it actually carries that much, right now, right? If you go by that, that will mean 15 refueling trips to completely fully fuel the ship, because you will need 15 of these 100-ton propellant transfers to get there. Why is it that it is 100 tons and not more? It has nothing to do with the materials or anything. If you made that of carbon composite, like they were originally planning, it will still be, in the same order of magnitude in terms of how many refueling trips, because it is all driven by the physics. Roughly 2 to 3% of your rocket, it's usually the useful amount of payload that you can get into orbit, which means you're going to need a lot of refueling trips to be able to fully fill your second stage, no matter what materials it is being made of. In fact, depending on what materials you use, because if you use, for example, when they were wanting to use carbon fiber, one of the problems of that is that you need a heat shield on the windward side, but you probably also need one on the leeward side because that material cannot sustain high temperatures. Whereas steel, in this case, they don't need that heat shield on the leeward side. They can just have the bare metal, essentially. And so that is one of the trade-offs that they did very early on. If for whatever reason in the future we were to find a material that, it's like, oh, we can get rid of a bunch of this mass, it will make all of this thing more efficient and everything, but it will not change the whole thing of needing 10 refueling trips or anything like that. It may cut maybe 1 refueling trip at most, but that whole deal is more down to the orbital mechanics and the physics of launching something into orbit than rather, it doesn't matter what material you use to launch that thing into orbit. You will need some kind of propulsion breakthrough, I guess.
And this is why we go to Alex for all the science questions. When you talk about material science, aerospace engineering, we have a really, really great crew here. And then we also have EJ. I'm kidding. I'm kidding.
What?
EJ, one of the things they're testing on this flight, and they wanted to test on Flight 7, which they couldn't get to the re-entry phase. And we're going to go through the whole phase of the flight, but I wanted to focus in on the heat shield. There's a lot of tests going on this flight when they get into orbit. Again, we're going to go through the launch profile later on in the show. But one of the things is the actively cooled heat shields. Some of them are aluminum. Some of them are shorter than the normal heat shield. And Elon has put out, Elon Musk on X, that perfecting the heat shield for this type of vehicle, again, this is groundbreaking stuff, is something that's very difficult. So talk us through some of the tests that they're going to see back at the control room for today's flight.
Okay, so principally we got 3 different types of tiles on this one, Gene. The first one are basically the tiles that they've been running since Flight 1. Well, I mean, this is a little bit of a different, let's say, recipe, I suppose, for the tiles would be the right way to say it. We have the standard kind of fibrous tiles, the unifibrous tiles that we see, which is just basically the hexagonal tiles that you see all over the ship. Now, if we we get a shot of the ship here, we can look and see that there are kind of some tiles that are indented a little bit. They look like they're almost a little bit shorter, like in terms of depth to like the stainless steel, right? They're a little bit shorter. Those tiles are aluminum tiles, believe it or not, or aluminium for the rest of the world, right? Right. I like going right down the middle and saying aluminum. Just confuse everybody. That's kind of what I'm here for. No, wait. Anyway, so those aluminum tiles are there to make sure they're basically gauging depth. Like what SpaceX is trying to do is figure out how much those tiles will ablate, because aluminum does not really withstand re-entry heating very well. So it is going to ablate off. It will burn off, just like a heat shield would. SpaceX has those tiles on there to test areas where they may or may not need tiles. Obviously, if they get an image of this thing coming down into land and one of those aluminum tiles is still intact, well, if an aluminum tile can survive being there, the bare skin of Starship stainless steel will absolutely survive going through there, right? So that's what they're using to test with the aluminum tiles. The other type of tile that we have on there that I'm not 100% sure where those tiles actually are basically actively cooled tiles or transpiration cooled tiles. Basically what SpaceX is trying to do with these is the tile basically has a bunch of little holes in it, and that hole is attached to plumbing, like think kind of like a tile shaped shower head almost. And what these things do is basically they outgas methane during reentry. And what happens is with this tile is that methane gets basically caught between the reentry heating and the surface of the thermal protection system on the vehicle, providing a cool column of gas. It's kind of similar to what you see with the supersonic retropropulsion from Falcon 9 when
you
it
had
comes.
to say it.
Yeah, of course.
You had to say it early. You're going to say it many, many times.
Of course. I'm going to find a way to put that in here. That's my favorite part. So when Falcon 9 comes in and does its entry burn, right, it's firing its engines into the reentry heat, and that envelops the booster in a cool column of gas because the booster's flying business end first, right? It's flying with the engines facing towards where it's going. This transpiration tile does something very similar to that, obviously with no like rocket engine. It's just shooting methane out the side instead of, the carbon byproducts that Falcon would, fly through. That's part of the reason why Falcon 9 is all caked in soot when it comes through, because it's been flying through its own exhaust. Exactly like that, where they outgas the methane, and the methane that gets caught in between the tiles and the reentry heat, and it basically absorbs all that heat instead of the tiles absorbing heat. It's it's not a new technology, but it's kind of the first time we'd see something like that on like let's say a fully and rapidly reusable spacecraft. So yeah, those are the three types of tiles that they have. Now, once again, I'm not really sure where they are, like what a transpiration tile looks like. First of all, I've never seen that. Have you seen one of those?
I don't know.
I'm not sure where those exactly are on this ship, but you can tell that it seems to be a uniform indentation of tiles on the thermal protection system if you take a look at it. It's actually super interesting.
I was talking with Alex earlier about that, and it's going to be very difficult for them to cover the entire ship with whatever the next level of heat shield or thermal protection system they decide to go with. They're testing many of them, and that's been probably, as we say, the hardest part of the entire development process. And I want to remind everybody that what you see on screen is research and development. This is the 8th test flight of the largest vehicle ever flown.
Yep.
This is the tallest, most powerful rocket. It surpasses the Block 1 ship that flew from test flight 1 to test flight 6. Because 7 was also Block 2. And going forward, we're going to see potentially a Block 2 booster and a Block 3 booster with integrated hot staging ring. And so everything you see is just research and development. And, SpaceX's mantra is fail early, reiterate, and then move on to the next thing so they can correct it. So when things go wrong, they get data back from that, and that's how they learn, and that's how they then make the changes and go on to the next flight. They're already looking to Flight 9 and Flight 10. They have the boosters ready to go. And on Flight 7, they caught Booster 14. This is Booster 15 with Starship 34 up on top of it. You can see it there on your screen. Let's talk about the launch tower for a little bit. Oh, before we do that, I was just going to say it's a really nice shirt.
Oh, the Flight 7 shirt.
Yeah,
that's
a really nice shirt. Today, if you can see,
awesome.
If you can see us on screen, you can't see. You can see the rocket, but they'll bring us up. We're actually wearing some of our own stuff. You can find at shop.nasaspaceflight.com, and in fact, you can go out right now and you can pre-order. You can pre-order the Flight 8 patch, and we'll get the guys in the control room who are doing an amazing job. We'll get them to bring those up so you can see those on the screen. And if you pre-order them now, we start shipping those Flight 8 patches right around the end of March, probably the end of March, early April. We'll see those, but we'll bring those graphics up so you guys can see that in a minute. Let's talk about the launch tower real quick. What are those big arms at the top of the launch tower that you see there?
Well, those are the chopsticks. Those, I mean, we saw on Flight 7 what those do, the fruits of that labor there. They do catch the booster when it comes back down, but they're used for principal integration of the vehicle. Those chopsticks can move from one, they can actually kind of move left and right. And what they do is SpaceX basically tows the booster. They roll out the booster from the production site. They get it inside of the chopsticks. The chopsticks lift it up, put the booster on the OLM, and then they do the same thing with the ship. Those two things basically grab the sides of the Starship. They pick it up and they crown it, which we did see this last night. So that pad is used. That huge tower isn't like a crew access tower, like where you have all the umbilicals going up, like what you'd see with a Saturn V. That thing is actually your integration structure and your launching structure and your landing structure too, because what we saw in Flight 7, like I said, is when that booster came back down, right when the booster was basically hovering over the OLM, those chopsticks slam home and caught that booster. It was the second time that it happened. It actually happened the first time on Flight 5 with Booster 12. We don't talk about what happened to Booster 13 on Flight 6. It landed somewhere.
It worked as expected.
Yeah, it did work as expected.
Worked as
That's
expected.
right.
It had a communication problem with the tower coming in, so they decided to do a water landing in the Gulf. And again, that is exactly so a human on the boost back burn, and we'll talk about this during the flight here in about 2.5 hours. When the booster turns around, does the boost back burn, the human in the control center, they do their checks, they do their safety checks, and they manually command the booster to head toward the tower to land. And in fact, it actually heads for a space just in front of the tower in case there's an issue, and then it kind of crabs its way over. And it's really amazing to look at, and you'll see it on our cameras here in about 2 hours and 45 minutes because it takes about 15 minutes to get up and come back.
Yep.
Weather permissive, winds permissive, but it's really amazing. But they do a manual command to send it toward the launch tower, and then it's hands off. The rocket is talking to the tower. The tower says, "I'm good to go. Catch ready." The ship says, "Here I come. Get ready to catch me." And there was an issue, and that's why the ship said, "You know what? I don't have that communication with the tower. I'm going to go to my backup," and it worked as expected and did a soft landing out in the Gulf, and then did other things.
And what it did after that, we don't know. It did a swan dive. It got a perfect 0.0 on the swan dive. That's perfect,
exactly right.
Score, right?
Yeah.
So those chopsticks are used for, not only putting the booster together, but they're also used for actually getting super heavy, and then eventually a ship, hopefully not on this flight, but maybe in the future, depending on how good this flight goes, that'll be used to receive boosters coming back down, that catch it and put it right back on the pad, and potentially in the future, even ships coming back down being caught. Hopefully, there is nomenclature in the licensing for Flight 9 of the potential for a ship catch. But once again, Gene, you were talking about how SpaceX is constantly prototyping and constantly changing, and they fly often. You fly often, you fail fast, and you figure out what you need to fix. One flight is really contingent. The next flight is contingent on the previous flight. So like what we're seeing here with Flight 8 is basically a duplicate of what we saw with Flight 7. They're trying to make sure that they can, understand what's going on with reentry with the ship and also the plumbing that caused it to explode. And we don't want to cause Flight 7 to explode. They're trying to figure out and make sure that works. Just as Flight 8 is contingent on Flight 7, Flight 9 will be contingent on how good this flight goes. So we'll see. That's just how SpaceX does things. It's rapid prototyping. They're not afraid to have a ship blow up as long as everybody stays safe.
Yeah. And as you can see on your screen on the left-hand side, that's one of our cameras real close to the rocket out there at the launch site. And you can see some droplets hitting it. We don't know. We don't have a direct line to SpaceX. All we know is that as of right now, they are still aiming for this afternoon at 5:30 p.m. Central Time here at Starbase, Texas, 2 hours and 31 minutes from now. Now, here is the weather, and I'm going to bring Adrian in a little early to talk about this since they pulled it over on the screen. Adrian, talk us through what's going on right now, please.
So I'm not Ryan Caton, to completely make that clear. Ryan Caton is sick today, so Ryan cannot be in front of the camera being our cloud and map reporter. I'm not sure if we are able to bring in what I'm sharing in terms of map, But okay, remove that partially cloudy because that's actually in front of Starbase. That is the current situation based on the NOAA goes east satellite. And you can see there is a pretty big block of clouds right now. So Starbase, of course, in the lower left there. And what you cannot see, because right now the red ticker is a bit in the way, there is a bit of a corridor that is forming. There you can see it, right about the ghost. You can see it right at the end. There is a bit of a corridor forming of clouds clearing. The question is, will that corridor arrive in time? Will it actually properly form? Will we see like complete clearance of the clouds? We will see. But as of right now, it is a bit cloudy, and we can now, of course, also see rain at the launch site. And I want to also quickly echo what EJ has said before. Just because it rains, or just because the conditions don't look that optimal, that doesn't mean it is out of the corridor where SpaceX can't launch. It's just maybe an annoyance to us.
Yeah. And we have our own folks checking the weather. I'm sure Adam, who is typing right now, is checking the weather, trying to give us an update. But as you see the dark clouds or that, we don't actually know the tolerances of the vehicle itself. We have a pretty good idea and approximation. As you said, just because it's got some rain, just because the clouds look a little bit low, that doesn't mean that they can't punch through those. And if a company is going to test their vehicle in all types of situations, imagine a 747 launching and landing in ice and snow and rain and wind. And that is where the future of Starship and human spaceflight, that's the desire where they want to take this vehicle. To be that reliable and that usable. So if they're going to launch in inclement weather, this is the company to do so. I want to get back real quick and talk about the overwhelming support that we get from you guys. And thank you very much on YouTube for your tips.nasaspaceflight.com, your questions, your super chats, and also going out to our store. I wanted to, Adrian, I'm going to send it back to you. I know there's a lot of people to thank because they come in hot and fast. And so we want to make sure that we say thank you to those people. So back to you, Adrian, and then let's get a question for Alex in here.
Absolutely. I will first issue and also my my store as like also like watching the store here. I will issue the first warning about the patch status. We are over halfway gone on the Flight 8 patch. It's like I'm watching it and I'm just making sure that everybody knows we are over halfway gone. But let me also thank some support here, because there's tons of people to thank here that enable all of this. Starting with RC Horseman, a very regular name here we see here all the time, gifting 10 Red Team memberships. Thank you so much, RC Horseman. And of course, thank you for all that you do and all your support. Then we have a super chat from Marco here. Let's see here. Thank you so much. Matt with the store message saying that they watched all 8 flights live with NSF. Every single one of them. That's really amazing. Thank you so much, Matt. Alex here, I assume another Alex, gifting 5 Red Team memberships. That's really cool. You can gift other people here a Red Team membership, and I'm not even sure if I'm allowed to say this, but there's like a production behind the scenes where you can even hear the man, the myth, the legend, Kevin Michael Reed, I think, making calls behind the scenes sometimes. So I'm just promoting that here right now. There is this mythical place called the production behind the scenes that is available for members. So that is also going on. And let me see here. Then we have Turtle Sanctuary with a $10 super chat saying, happy to see one of my favorite commentators on screen today, and you guys too. It's very open. It's
Well done.
That's recipe for a fight between guns, I guess.
Yep. And Alex, I have a question that is perfect for you. Greg, we talked about the purge system earlier that they use now also in the attic in the ship to purge fires. And so the booster system and the ship system use different different things for that. So the question here is from Gregory, why use CO2 over N2 or vice versa for fire suppression? Don't they both do the same thing?
Yeah, that's one of the questions that we have had, sort of, when we got that update. One of the theories behind that is that maybe they cannot load that on the ship through the quick disconnect arm, because maybe they don't have that connection to put it in the ship on those COPVs that we were talking about, those bottles, right? So the one that maybe they could load is that nitrogen, right? And so that's one of the theories that we have, that perhaps for the booster, they were able to do that and modify that to be able to load the booster with CO2. But unfortunately, it could be that the ship is just, they don't have that connection to put it on the ship. So that's why they did nitrogen. Nitrogen does very well as well to mitigate any fire.
And they're using that in the attic as well as part of the new purge system, but they use it all over the place. They do it on the booster before they light the landing engine. So when the booster comes back in, you see this big vapor cloud. Some of that is just punching through the air, EJ, and the other part of that is they're purging all of this nitrogen or carbon dioxide. Excuse me, I think it's carbon dioxide as well. They purge through there to make sure that any fires that could be in there is out. As you said earlier, fires in rockets bad unless it's going out the back end, right?
If you got fire going in more than one direction, Gene, you got a problem. With a rocket, you want the fire to go ideally in one direction, and that's out the back.
Yeah, and that makes the rocket go uphill. So, speaking of that, we are 2 hours, 23 minutes from a potential liftoff of Starship Flight 8, Test Flight 8. And, we were looking for a couple things on this one. I mentioned earlier, we're looking for a couple of things. On Flight 7, they had 10 Starlink version 3 mass simulators in the cargo bay. Unfortunately, we didn't see those deployed. And this time around, they have 4 in the payload bay, and these are just Starlink. They're just blocks of metal. They approximate size and mass of an actual Starlink V3. And when I say Starlink, I'm talking about obviously the satellite constellation that supplies high bandwidth internet all over the planet.
Mm-hmm.
Thought you were going to say something instead of mm-hmm.
No, I was thinking about if you wanted me to go into Starlink. So Starlink is the constellation that SpaceX is working on. It's a crazy big constellation here that's basically is a bunch of cell towers that are floating around the planet. They're working on direct to cell, and these bigger Starship satellites that they're going to use with the Starship program are basically able to generate more power so you can get better connectivity. It's a bigger satellite, bigger solar panel. You can generate more power, you transmit a bigger signal. It's pretty straightforward stuff. But this satellite constellation is really kind of revolutionizing the way we think about how to get internet. I mean, you can get a Starlink antenna, you can get it anywhere. Like, not to just shamelessly plug it. It's a really cool piece of kit. And these new satellites that they're going to put on Starship eventually. I mean, the ones that they have on there are basically mass simulators. It just looked like an amalgam of steel beams that are kind of in the shape of a Starlink satellite, right? And I think that's really more to test the deploy mechanism than anything. And they're not going to test the satellite. Those Starlink satellites will obviously re-enter with Starship, only they'll re-enter, they'll burn up, and hopefully Starship won't, right? I don't want to put any bad juju out there. But Starlink's actually a really, really cool and interesting piece of technology. It's kind of the next level. It's kind of the Jetsons future that we all wanted, right?
Exactly. On your screen, you see several of our cameras. We're gonna and there's a Starlink lifting off in the lower right-hand corner, one of the many Starlink launches we cover here at NSF from the Space Coast. And you can check out our Space Coast live camera on YouTube, also our McGregor Live. It does the engine testing. And then Starbase Live, which is what you're seeing on the other cameras on the screen, lifted off by a Falcon rocket there. In the upper right-hand corner, that's the tank farm. That is going to be the commodity storage and some subcoolers and chillers and the things that they use for the propellant of the rocket. And we're going to go to Alex because I want to talk to him about that propellant farm. We see some vapor there. We see some chillers and subcoolers. And when all of these things are working properly, talk us through the propellant of Starship and Super Heavy booster and what to look forward to as we go into this countdown.
Yeah, so right now you can see a lot of that vapors. A lot of those are coming from those vaporizers, the ones that have a lot of tubes in there, sort of like a spaghetti kind of thing, right? In there, those are used to be able to boil off a bit of that nitrogen and be rather the other way around. They use nitrogen to be able to boil off some of the materials that they use to be able to backfill the tanks on the main storage tanks. So in hopefully, less than 2 hours from now, we're going to have that start of propellant load at T-minus 46 minutes. When they do that, they're going to pump a lot of propellant into the vehicle, which means those storage tanks are going to decrease in volume. So the remaining volume, in order to not pull a vacuum, they need to put something back there, something that creates a pressure. And so that's what they're doing right now. They're not filling it up right now. What they're doing is they're spooling up that system that allows the back pressure fill to happen. Apart from that, we're also sort of waiting to see more activity from the subcoolers as well, which are behind this system essentially. Those subcoolers will bring the temperature of the liquid methane and the liquid oxygen below their boiling temperatures, and then go into their their chill down of the lines that go out to the launch mount and also the lines that go out to the tower. So that's one of the things that usually happens. We'll see OLM vent and tower vent, right? Those often happen, somewhere in between T-minus 1 hour 40 minutes and 1 hour 20 minutes, right? It's a bit of a leeway there that they have, but usually around those times. If we don't see one of those by T-minus 1 hour 20 minutes, you start wondering, maybe we're into some kind of delay or something like that. There's a 1 hour window, so they can delay up to an hour into the window and they'll still be good to go, right? We've seen this in the past. We've seen in the past that we've arrived to the usual time when that OLM vent or tower event should happen, and we've seen that it's not happening. It's like, is this delaying? And then suddenly SpaceX is like, oh, we're moving to this other time, right? So we're going to keep a close eye, of course, in about 40 minutes or so to that OLM vent, that tower vent. They have some margin there up to 20 minutes. We've seen that, right? But if we go to T-minus 1 hour and 20 minutes, aka an hour from now, and there's none of that, you start worrying. So we'll keep an eye on that. I definitely have all of our cameras open and everything to be able to make sure that I don't miss any of that.
And some of the camera angles that you see are of the roadblocks. And we talk about the roadblocks because they are special in their own way. They have a soft roadblock, and then they push it back to very specific times that when the rocket starts to load and we start to see that propellant, as you were saying, Alex, when you say, the propellant starts loading, we do have to super chill these lines up the tower, right, EJ? When we start seeing things spool up from the tank farm perspective, they're not just rushing fuel into this rocket. Talk us about that process real quick.
So basically, the lines need to be thermally conditioned, right? You have really, really, really cold propellants here in the form of liquid methane and liquid oxygen. And not only do you have a lot of propellants, but you got to move a lot of propellants really quickly. You got to move them quickly into Starships because, Starship is designed to be rapidly reusable. They want to launch this thing a lot. And if the fueling takes 10 hours, right, that's not rapidly reusable. It has to be as quick as a fighter jet, or not a fighter jet, maybe a passenger liner, right? Mm-hmm. But we're not talking that quick. I mean, Starship is a lot bigger, carries a lot more fuel, but these lines need to be chilled down. If you don't chill these lines down, you take these really cold propellants that you're trying to move into the booster quick, right? You take those propellants and basically heat them up. Now, liquid methane and liquid oxygen, to the uninitiated nerds out there, don't worry, we'll get you up to speed here. They're boiling propellants. They're cryogenic propellants. In order for methane to exist as a liquid, and for liquid oxygen to exist as a liquid down here, where us mere mortal humans exist, they need to be extremely freaking cold. And when they're cold, right, they start boiling, right? So if you take these boiling cold propellants and you put them through these lines, they'll start to exchange the heat with the lines, and that'll bring the temperature up. It'll bring the temperature up of these propellants where they will evaporate, and they'll turn to gas. And that gas inside of the line can cause basically pneumatic pressurization, and you can basically have a geysering effect, like a Nerf gun, right? It uses pneumatics to shoot the darts out, right? You have that, only instead of the dart coming out, you have the remaining liquid propellant in your line. Don't want that to happen. So in order to get those propellants into the Starship fast, right, and in order to get into it safely without causing the pipes to pop like a balloon, right, you gotta thermally condition these lines. It does take a second, but we should be able to see when that happens. You'll see ice accumulating on the fuel lines when they go, and oxidizer lines when they go to do it.
And one of the other things that are special about this ship on Flight 7 and Flight 8, and EJ, I'm just going to stick with you for a little bit, are the catch pins. Now, we talked about the thermal protection system and how it wrapped around the ship, but they actually pulled 6 rows off of both sides to attach. These are non-structural catch pins because they're thinking for the future, right? They're thinking for Flight 9 and beyond.
Yeah, you're talking about the catch pins on the ship.
Yep.
Yeah, they're kind of duds, I guess. It's just a shell of where the catch pin would be. But like how we saw the boosters get caught on Flight 5 and Flight 7, SpaceX is also looking at bringing those ships back and catching them with the tower again. They would be doing a similar type of landing burn that we saw way back in the original Starship test flights from SN8, SN9. I mean, those didn't end well. SN10, and then ultimately SN15. You guys, let me know if you were around during those times, because that was fun. That was classic Texas tank watching, right? Basically, it's going to do a landing burn. Hopefully not like 8, 9, 10. It's going to do a landing burn kind of like SN15 and kind of.
And it seems we have a quick moment here where the hotel will be back any second now. So let me quickly thank some... before we do that, apparently we have a video here that will give you a bit of better overview of what will happen in the next 2 hours and 15 minutes. So let's watch that video and listen to what we can learn.
On the day of a Starship launch, many events need to happen for the flight to take place successfully. One of the first events is the clearing of ground hazard areas, resulting in the closing of Highway 4 and Boca Chica Beach several hours before the launch, something that has already happened. At this point, we now have 3 different roadblocks established along Highway 4. The first one, nicknamed the Soft Checkpoint, is located about 15 miles from the pad at the intersection of Highway 4 and Oklahoma Avenue. Beyond this roadblock, only those with property there and law enforcement officials can pass. This also includes SpaceX employees. The second roadblock, nicknamed the Hard Checkpoint, is located at the intersection of Highway 4 and Richardson Avenue. Beyond this location, only essential SpaceX personnel and law enforcement officials can pass. A third roadblock is located on Highway 4 right after its intersection with Lyndon B. Johnson Boulevard at the end of Boca Chica Village. This intersection is the last one on Highway 4 before arriving at Boca Chica Beach, so up until now, it was used to control direct access to the beach. Soon, we should see this roadblock being cleared, if it hasn't already, as it's too close to the pad for anyone to safely remain there during a launch. With the ground hazard areas closed, SpaceX should now be in the process of conditioning the tank farm. During tank farm conditioning, the subcoolers on the tank farm are slowly filled with liquid nitrogen, and the liquid oxygen and liquid methane propellants should be flowing through the transfer lines from the ground tanks to the subcoolers. During tank farm conditioning, you'll probably see venting every now and then, including the now famous Pope vent. This is completely normal and expected. Although the timing can vary, especially if the launch is delayed into the window, this conditioning should last until about 1.5 hours prior to launch. This is when the conditioning goes from the tank farm to the propellant lines that go to the launch area. This conditioning will see the flow of propellants from the subcoolers out to the launch mount and launch tower. This process will be noticeable because a vent will appear on both the OLM and the tower while it's happening. The vent on the launch mount will start off weak at first, but will progressively grow in intensity as we get closer to the start of propellant load on the booster. As for the tower vent, it'll start at a normal intensity and will stay active for a few minutes before weakening or completely disappearing. Then, it'll come back again and with significantly more power as we get close to the start of propellant load on the ship. At around this point in the countdown, we should also see venting from the booster chines closer to the launch tower. This is a sign that carbon dioxide is being loaded into the tanks, which will feed the vehicle's fire suppression system during flight. While this conditioning is happening, the SpaceX flight director will conduct a poll with operators to decide whether or not to proceed with propellant load. Here's hoping that later today, everything is go for Starship. On the day of a Starship launch, many events need to happen. On the day of a Starship launch, many events need to happen for the flight to take place.
And we are back. Hello, everybody. We're still working on getting the hotel crew back, and in the meantime, Alex and I will be taking over. Apparently, and I will quickly confirm this, you need actually power to run cameras. And there's not that much at the hotel right now. So that is the reason we have worked to get them back. And in the meantime, you're stuck with Alex and me.
Live coverage,
Alex,
y'all.
yeah. Let's talk about weather limits here, because weather is a bit of an iffy point here. What determines actually if a rocket is in its weather limit? How do these weather limits come up? Like, is the rocket company just making them up? And why are weather limits even a thing?
Well, you normally want to. So when you design your rocket, right, you know its limitations, things like bending moments and things like that. Like, for example, Falcon 9 in essence, it's too long, for example, to go through very high wind shear at upper altitude, for example. When it goes through max Q and you have one bunch of wind here and that other way, it's too long, and so there's this bending force, right, that could just snap it apart. You know those limits on your vehicle, and those will determine essentially those weather rules that you need to apply to it. There are usually general rules. If you are, for example, at Florida at the Space Coast, there's usually these, widespread rule for everyone that operates in that spaceport, for example, that the range puts in place. Maybe some rockets can fly in very extreme weather environments, but the range itself, they want to keep those rockets still, within those parameters. So sometimes you'll see certain rockets are like, we could fly, but we are, breaking the rules of the range and things like that. SpaceX operates their own range, so they establish their own rules, right? So that's kind of at least at Starbase, that's what they do. So they can adapt more to what Starship can handle. Unfortunately, we don't know any of those details, right? It's one of those things that we can talk about all of you want, about the different ways and different rules that could be there, right? But we don't actually have hard numbers and like a list given by SpaceX of what are the rules and what are the different constraints. Of course, you usually look for liftoff winds, upper level winds, the wind shear, sometimes the temperature might affect some of the ground systems, maybe, like, you don't know, right? Things like even proton flux from the sun can affect your electronics, because you're going out into space, right? And so you're out of that, most of that shielding from the atmosphere. There's still magnetic field around Earth and whatnot, but you get out of a lot of the protection of the atmosphere and so on and so forth. And so they look at everything, and again, we can make a whole list here of what those uncertainties and rules could be, but we don't have the hard numbers, unfortunately. Maybe one day SpaceX will release some of this information, or at least we'll have to piece it together by different comments from officials and whatnot. We kind of have an idea already of Falcon 9, like no more than 23 knots winds and things like that. Like, those things we know now, because over time the program has been already 15 years into, in length. We've been able to hear all of those comments and all of the different numbers and everything, and it's launched a lot, for more than 450 times now. So of course we've been able to get all of those numbers in our memories and whatnot. And so yeah, that's essentially the gist of it, I guess, because we could go on forever. But we are 2 hours and 6 minutes away from that launch, and I think people are more interested in other things.
I apparently was talking, but muted. It's the thing. Then another question here we're getting. So today is a interesting day because they want to release some Starlink demo satellites, Alex. And people are wondering, so they released them in space, and of course they are kind of on the same trajectory then as the upper stage. So one question we are getting is, how does SpaceX maintain separation between the Starlink dummy satellites and the Starship upper stage?
Yeah, so one of the advantages that they'll have on this flight is that they have planned a relight of one of the Raptor engines on Ship 34 about 10 minutes after that satellite deployment. So that's one of the things that they are going to be able to do in order to get away. Normally on operational flights, once they go into orbit, for example with Falcon 9, what happens is that the satellites are drop off, right? And they usually have their own momentum, right? Like they are drop off and that sort of momentum keeps them away. And then there's a waiting time until you are on the right location for the deorbit burn. In the case of the second stage, it is because they need to drop it off on an ocean. And most of the time it works, sometimes it doesn't. And when it works, they're dropping it off in an ocean, either the Indian Ocean, the Atlantic, or the Pacific Ocean, depending on what mission and what's more convenient, right, for the type of mission. And so what usually happens is that there's like a gap in time, and so that allows them, those satellites with that momentum, to get away, far away from that second stage. Because you have to think about another thing as well, especially in operational flights. You like those engines, if you are close to the Starlink satellites, you may blast them with that Raptor engine exhaust, right? Like once they go with Starship into orbit and deploy Starlinks or any other satellites, how do they even deal with that? Well, they just leave a little bit of time after deployment to do any other burns. And so we've seen that with rideshare missions and transporter missions, for example. They deploy hundreds of those at a time. And so they deploy a bunch, they maneuver into another orbit, and before that maneuver, they sort of wait. And in this case, if they were not able to do that relight, or even not do a relight, the time between the deployment of those Starlink satellites and the entry is about 30 minutes, which means that's about the same time that they have between the separation of the Starlink satellites on a Falcon 9 mission, right, and that deorbit burn. So it will leave enough separation time, to get away. Like say it's 1 meter per second separation. That's a lot of time. That's more than 1 kilometer, near 2 kilometers away from that second stage. So they could get decently far away from Starship.
Alex, we are seeing some venting here on the tank farm. Of course, we have seen similar venting now. I'm hearing we have a balloon. Are we able to show that? Apparently, yes, there was a... So this is interesting. This is a weather balloon that was just launched that is in the near proximities to Starbase. So apparently SpaceX is starting their weather survey and has started to launch weather balloons. Alex, why do they do that?
Well, they kind of need to know how the weather will be up there, right? The winds and conditions in general that are going to be aloft on this launch trajectory. And so that's what they do. Obviously, they're tracking. It's not just important to be able to know how it'll be in the future, but also how it is right now, because you want to see the trend. We are 2 hours away from that opening of the window, and so you want to launch it and get the data from now. Right? It also takes a while to get up there to altitude, by the way. So it's not immediate, right? But you normally gather this information before the launch to sort of make a sort of registry of what are the winds, what are the conditions up there, and then you can see trends before the launch. And if you see things, for example, like shear and there's more in this direction, there's more other direction, or you have winds increasing, then you're like, maybe we're not in the right track, right? You can also make forecasts because you have more hands-on data of those conditions up there, and then you can run forwards those 2 hours until the opening of the window. And so that's very important to have at hand, and they do it now again well before that launch time to get those trends, to get those models running, and be able to make sure that they are set up for launch in 2 hours from now.
And I am hearing, I'm doing a quick of a improv check here. The place that has no power has power again, I'm hearing here.
We've done a lot of launch streams in my day, in your day. Have we ever had the entire hotel go out of power?
I think they popped the transformer.
They were like, hey, watch this. Yeah. Click, click.
Hold my liquid method.
We're back.
We're back.
What were you guys talking about? Yeah. What were you guys? We've been running around like rat. We were like, What have you guys been talking about?
I can tell you that the moment I saw on our back channel the message, power went out at the hotel. I was like, oh.
Yeah, oops.
It's
No,
one of those
we are
things.
just talking a bit about we were doing a bit of a Q&A here to fill the time until you're back. So, Gene, I'm handing over the virtual reins here to you again for this show.
Great, because I have no idea what's next. I appreciate that, Adrian.
I actually also have no idea. I can do support because I have some very generous support.
Yes, please.
Let me start with the Space Pope here with a $500 super chat.
Wow.
Thank you so much.
And sorry we just got to that because while this was ongoing, we didn't do support. Blessing to the following: this flight chat, Jack's hat, and the NSF team. Positive thoughts go out to the Earth Pope and hopes for speedy recovery. Hopes for a safe flight, and as always, choose kindness. In the name of the Flame Trench, the stage set, and the Holy Space Ghost. Mayone. Thank you so much. I mean, that's an incredible amount of support. And we are so grateful for always when you're here, Space Pope. So this is not a one-off. This is a very regular in the chat. Thank you so much. We also let me go to that. Have Joa and William Weaver both gifting 20 Red Team memberships. Thank you both. Also very regular names here. I'm so grateful for that. Hope you're enjoying the show as always, and thank you for, as always, hanging out with us. And we have we have Bob here coming in with a super chat saying the Kevin might read something strong to drink fund. Thank you for that. And yeah, with that, I think we are through with that. So, Gene, Starship, huh?
Yeah, Starships, it's out there somewhere. The weather has not improved. The power, for now, is stable, right, EJ?
Knock on wood.
Knock on wood. We're saying that. We are under 2 hours now from a no earlier than potential liftoff. And again, even though our long-distance cameras might not be the best for the weather today, it might not be cooperating, we still have our close-in cameras. We have our remote cameras. We have the cameras positioned by our really talented photographers here at NSF, and they are going to bring you, hopefully, knock on wood, some amazing views of the launch and potentially the recovery of the booster. And then, of course, we'll have the feed where we're going to watch Starship do what it does in space and hopefully, not like Flight 7, get into its proper trajectory, which is a free return trajectory that takes it over to the Indian Ocean. And I have no idea where we are in the production room, but I know. Did we do the timeline video? I think we did the timeline video.
Yes, we did.
We did the timeline video. Okay, great. Do we want to go to? Let's see. I'm kind of figuring this out because when the power went out, everything did its thing. But as they say in show business, the show must go on, right, EJ?
Oh yeah, we improvised, we adapted, and we overcame.
That's exactly right. That's not going to help us. But we are seeing the same venting from the commodity storage. We are seeing the tank farm spooling up. And I want to go to Alex and ask what's going on with what we're seeing on the screen. And we see these tanks spin up and more of the venting there.
Yeah, we're starting to see a little bit more activity there on those vaporizers, and transfer lines are also getting chilled down as well, moving all of that liquid oxygen and liquid methane out to those subcoolers. Those subcoolers, they essentially have like little lines running through them. Well, not little, but they have lines through them where that liquid oxygen and liquid methane can flow through, and then inside there's this bath, so to speak, as they call it, in liquid methane, in liquid nitrogen. I'm a bit nervous right now because we're getting very close to the launch, and so things are popping in my head. And so right now we are essentially transitioning from getting those propellants that are on the ground tanks and putting them out to those subcoolers that are now being cooled down, chilled down, getting all of that prepared for that for those same propellants now to flow out to the launch mount and the launch tower. That's going to be the next step. After this, we're going to see that OLM vent, that's gaseous oxygen venting out of that vent, and then from the tower, we're also going to see a similar vent as well, also gaseous oxygen. we're going to see a lot of activity also around that time as the subcoolers become a lot more active. We're going to get also potentially some action from the booster side of things, because those chines, two of them, those aerodynamic triangle pyramid thing, prism things, I guess, that you could see on some of these shots on the booster, two of them, the ones that are closest to the tower, those carry CO2 tanks. And so that CO2 is loaded liquid form. It's very cold, and so they vent. And we'll see some of that venting, hopefully, as we come down here.
One of the things that we do going into this is we normally see activity from what we call the Pope vent. Now, the weather and the clouds in the background make it very difficult for us to actually see that. Are we seeing that? Because it looks like we are seeing venting from that vent on the left, that little stack that comes up. But I can't confirm or deny that based on the picture that I see. What do you guys see? Alex, I go to you.
That vent is part of the whole process of getting the tank farm ready. What we're seeing there in that particular vent, though, is gaseous nitrogen, part of that system to be able to cool down some of the systems, especially related to the recondenser, the vaporizers, and whatnot. So that is different from all of the other venting that we're seeing, but it's part of the process, right? Once we see that and we are close to a launch, we know that things are getting ready, that things are getting primed, I guess, or conditioned for that tanking. But yeah, that won't happen though until 1 hour from now. It takes a bit of time. It's not just, you slap your fingers or something like that and suddenly it's all ready to go, right? You need to condition all of that. As EJ was explaining before, these things just a few hours ago, they were at ambient temperature. They were at whatever temperature it is right now at Starbase. And so you're going to run really cold stuff through them. You're going to get flash boil off, materials may there we go, that's the temperature, 22°C. Thank you, Kevin. And 71.6 Fahrenheit for those that use that. And so you can get a lot of bad things if you don't actually condition those lines for that propellant.
How long does it take to actually fuel the vehicle, and how much fuel does it carry?
About 46 minutes from the first action of loading propellant until T0. That's about 46 minutes. And they carry about 1,500 tons of propellant. It used to be 1,200 tons of propellant on the ship, and about 3,400 to 3,600 tons of propellant on the booster. So more than 5,000 tons of propellant on board this rocket. It's the heaviest rocket ever.
And that's why we were talking earlier about how many starships it would take to refill another starship, and they're going to have a tanker variant. And let's discuss that just for a few minutes here. Going forward, if Flight 8 is successful, we're going to see Flight 9 and so on and so on. We're going to see lots and lots of flights of this test vehicle. But we're also going to see lots of variants of this test vehicle. EJ, talk us through some of the variants that we could see if you had a crystal ball to look into the future.
Okay. So the important thing to understand here, Gene, is that Starship is not, it is a rocket, right? But you got to understand what SpaceX is trying to do with this thing. And in order to understand these variants, you got to think about it kind of like an airplane. SpaceX wants airline-like operations. So you got to think about these variants like you think about a variant of an aircraft. We have kind of Starship Prime, I guess, which is the one that, SpaceX wants to send to Mars. Think of that like kind of a passenger plane, a jetliner, right? And then you have the tanker variant, the one that, is designed to refuel starships, the first mentioned Starship in low Earth orbit so it can go to Mars, right? That's the tanker variant. It's similar to how you have a 707 and then you have a KC-135. A 707 moves people around, a KC-135 moves fuel around, but they're the same. It's all based off of a 707 at the end of the day. I understand, people, the aviation geeks are going to grill me for that one, saying the KC-135 is not a 707. It's a different thing. Yeah, I understand. They're all based off of the same chassis, though, so to speak, right? These variants of Starship that we're going to have is one used for refueling, one used for people. There's going to be the human landing system variant, which is technically another one used for people, but it's going to be slightly different than the one that they're going to go to Mars, right? Then you have the depot Starship, which is basically on-orbit fuel farm, which is supposedly going to be a bigger one where all these tankers will go and refuel, and then the depot ship will refuel the ship, either the HLS or a Mars-bound Starship in the future to, do things on the moon and Mars. That'd be pretty cool. I kind of want to see that. But you got to think about it like you'd have different variants of a passenger plane. Like there's there's cargo versions of passenger planes, there's tanker versions of passenger planes, and then there's passenger versions of passenger planes, right? These different variants will basically allow Starship to go wherever you need. Like, obviously, the first places where Starship is going to go outside of low Earth orbit is the human landing system for the Artemis program. But in the future, these operations could afford you to send hundreds of ships all at once out to Mars in a transfer window. And basically, once you're refueled on low Earth orbit, you're halfway to anywhere per the delta V equation, right? So you could pretty much go anywhere with just these three variants: the tanker, the depot, and the passenger ship. Go wherever you want. You move cargo wherever you need to in the solar system, which would be great.
On your screen right now, you see the full stack. That's booster 15 on what we call the orbital launch mount, but and then on top of that is ship 34, and in between there is the hot staging ring, which is a piece that can be removed and put on, and that was put on, EJ, and it's kind of a stopgap measure. When for the first flight, they were all actually kind of rotating things and then the entire ship and then detach them. And they were trying to use as little energy as possible to do so. When the first flight obviously did not go as planned, but it gave them a lot of data, let's be honest. And they've made a lot of iterations. And one of the iterations they did was to add that hot stage ring or interstage in there that allows the venting of the first stage. So talk us through how the hot staging or stage separation works on Starship and how it's different from, say, a Falcon 9 that we see launch.
Okay, so if we want to start with Falcon 9, Falcon 9 uses pneumatic push rods to actually separate. There's 3 on the rim of the interstage on a Falcon 9, and then there's one that kind of pushes up the nozzle of the Merlin vacuum engine. Now, those are hydraulically actuated from nitrogen, or it could be helium, whatever. It's a pneumatic system. It could be either one of those. I'm not 100% sure, but you got to understand, Gene. Like, if we were going to try to do that with Starship's a lot higher mass. That's a lot bigger of a system, of a separation mechanism that you would need to push this thing apart. And then, obviously you have more moving parts to a vehicle that already has a lot of moving parts, right? So what you got to do here, what they wanted to do with Starship is basically try to eliminate all of that. So what do we have on the ship here that already can provide us a way to separate, right? Well, the engines can get you separated pretty quick. They can get you separated pretty fast, and they could get you separated away from super heavy really, really quickly. So instead of coming up with some complicated separation mechanism using springs or some type of pneumatic drive mechanism, I'm sure I could picture like the SpaceX engineers having this conversation. Why don't we just fire the upper stage engines? It's worked before. It's worked in the past, right? Now, so what that hot staging ring is primarily there for is for when Starship's engines actually ignite. There's 6 engines on a Starship on the upper stage. There's 3 vacuum-optimized Raptor engines, and then there's 3 sea-level Raptor engines in the center. The first engines that ignite are the 3 vacuum Raptors, and their exhaust has to go somewhere because they're firing while it's still attached to Super Heavy. Super Heavy shuts off most of its engines, a point in the timeline that SpaceX calls most engine cutoff instead of main engine cutoff, like for a Falcon 9, right? So with 3 engines ignited on Starship and 3 engines ignited on Super Heavy, the vehicle never stops going under acceleration, but the Starship fires its engines, the exhaust goes out that hot staging ring, and basically Starship shoots off into the wild dark yonder here. So this mechanism is a lot simpler, believe it or not, albeit a little bit more, a little bit more complicated. You're just firing rocket engines into your first stage. Yeah, that's fine. Nothing bad will happen. So, but mechanically, this is a lot simpler than some type of separation mechanism. So SpaceX, I think with Flight 1, what they were trying to do is kind of rotate the thing a little bit, and then they ended up rotating the entire stack a bunch of times. So I think they said, let's do hot staging instead. Now, okay, I'm going to get a little bit in depth here if you got just a moment of your time, chat. Now, why? Why is the separation mechanism important? Why can't they just separate it and then fire the engines? Well, these rockets got to be under acceleration when they go to fire these engines. Down here on the surface, like when the first stage ignites, when Super Heavy ignites, all the propellants are settled at the bottom of the tank because of gravity. When you're flying and when you get to staging, that's not necessarily the case. If you shut off your first stage engines and then go to separate, right, you're not going to have a good feed because all your propellants are going to slosh forward. And then you run the risk of having one of your engines in just not fuel if they're ingesting ullage gas or they're ingesting gaseous, propellant, because the propellants are boiling. I mean, they're liquid fuel rocket engines. You don't put liquid in the liquid fuel rocket engine, bad stuff happens. So you got to keep this vehicle under acceleration. And SpaceX found a really ingenious way in that hot staging ring and using hot staging, which, believe it or not, is not anything new. There have been rockets that have been hot staging as far back as 1957. The Semyorka, a Soviet rocket, used a hot staging style mechanism. So it's not a new thing, but in this particular application where you have the biggest rocket, the heaviest rocket, and you need a separation system, then firing 3 engines and then firing 6 engines total, this is the simplest way to get it done. So that's what that kind of cheese grater looking thing that is halfway up the stack sitting at the bottom of Starship. It's vents in the side to allow for the gas from those 3 vacuum Raptor engines to vent in that split second where Starship has its first stage engines and second stage engines ignited all at once.
That was a very long answer, and I think you need a breather. That's why we have EJ. He's very knowledgeable about these things. If you're just joining us, we are 1 hour and 45 minutes to a no earlier than launch time for Starship Flight 8. And what that means is that the window opens, and I believe it's a 60-minute window, opens up, and SpaceX can look to launch anywhere within that 60-minute window. And that is the time that we keep counting down to. We look at the no earlier than time, or once announced, the T0 time, which of course we'll update and bring you that as well. Adrian, let's go to you. And when you find a question, why don't you send it back to us? I'll see if I can answer it, or we'll make EJ hyperventilate. But let's go ahead and thank some folks real quick, because I know the support has been coming in hot and fast.
Yeah, there's absolutely been a crazy streak of people joining Capcom. Capcom, of course, the membership level where you get access to our membership Discord, and they have been, so we have Anonymous, Falcon992RC, Chester Lovis, Isufanis, and Michael, all joining the Capcom membership team in a matter of a few minutes here. Thank you all for that, and I hope you get all the access to the membership Discord. Then we had Helena here with a $13 super chat, no message attached. Thank you so much for that. That's just a very generous amount of support with no message I can use to talk more about it. William Weaver, also a very regular name here, gifting 20 Red Team memberships. Thank you so much for that. And then we have also Wood4000 joining Capcom as well. Thank you all for this very generous support. Leon Fisher here with Super Chat saying, awesome job everybody. Do you think we will ever see a dual launch? Picture the patch. Alex, do we ever... Alex, I know you're a realist. Like, I know you're probably giving me, no, that's not possible but is there a percentage of a chance that there could ever be a dual launch?
Well, it's not that they couldn't, but in the current configuration, obviously, no. But that's why it is current, right? Like, they could just upgrade it and be capable of that. One of the things that they will need is to get a lot of more propellant storage, because right now they don't have enough for 2 full stacks. And once Starship gets, Block 3 and everything, and gets a lot more propellant storage, capacity and everything, you need an even bigger tank farm and things like that. But one of the benefits of how they run this is that the storage is common between both pads, right? But those subcoolers and pumps that push out things to the pads, those are separate. So there's a group of those for pad A, there's another group for pad B, and so they can essentially run the same storage tanks for both pads at the same time. There's a bit of a caveat there, which is there's a common pressurization system for those tanks, those ground tanks, right? But in theory, that could be upgraded as well. So you will need more storage tanks, and you will need some upgrades here and there on that pressurization system. But maybe there's a possibility of that in the future, and then they will be able to run both full stacks and launch within minutes of each other. I'm not sure about launching at the same time, but at least within minutes.
I would love to see two starships sitting on 2 boosters at 2 launch towers. EJ, I don't know about you, but one super heavy rocket is cool. 2 would be cooler.
I'd tell you, I'd love to see 2 rockets launch at the same time,
Or as Jack says.
Actually,
Go ahead.
Actually, they would be the same temperature, right? Because they're both aiming for the same. They're not cooler.
The puns have started, ladies and gentlemen. The puns have
boy,
started.
here we go.
Adrian in from left field with the cool pun. But as we say here, more rockets, more better, and that's one of the things that we look forward to. No earlier than the window opens in 1 hour and 40 minutes. And we're going to say hi to some folks in the field during this broadcast when we get closer into the countdown, because one of the big questions that we get, EJ, is people want to come down, and today is probably not the best day for visibility at great distances, but there are many distances here at South Padre Island over on the Starbase side of the Port of Brownsville where people can see the launch. So we constantly get questions of, can you see it from Corpus Christi? Can you see it from here in Mexico? Can you see it on South Padre? And I'll tell you, one of the cool places is the Rocket Ranch, the outpost at Rocket Ranch is one of the cool places that you can see that. And then, we team up with them and they're friends of ours. And it's actually the closest you can get. It's 4 miles from the launch site. And you've been out there. I haven't been out there.
Oh yeah.
What's it like?
Well, Rocket Ranch is like Gene was saying, it's about as close as you can get. It's about as close as you can get to this launch site. You're about 4 miles away. The people out at Rocket Ranch are really nice. That's where I actually fixed Jack's Land Rover the other day. I was fixing NSF cars to make sure they can get you these beautiful shots like you see on your screen there. Yeah, Jack, I mentioned it. So what? No, Jack's probably sitting there going, no. Do we have some venting activity there?
Yeah. And this you can actually see, this is the shot from Rocket Ranch on the outpost. And Jack is there. We're going to talk to him in just a little bit. Not right now, but we want to show you that camera. And that's as close as you can get. So you can still see it, even with some of the low fog today. You can still see that rocket really, really good. And you'll be able to see the launch and hopefully the booster catch when it comes back to the launch site. One of the other things, this is our shot from, I believe that's trailer. Is that our trailer?
Yep, that's trailer. That's the trailer shot in the danger lot.
In the danger lot. And you'll be able to see that. And we also have some cameras out in the dunes. We have one north of the launch site, one to the south, and we'll cycle through those close-up cameras. And they are remotely operated by folks at NSF that do a fantastic job. So just because you see our faces, don't think we're the ones doing this. We're not. There are some very talented photographers and engineers in the background, and we couldn't do this without them. And we also can't do it without you. So thank you very much for joining us today here on YouTube and also the Popular Science channel. We appreciate you watching this live launch coverage from NSF. We are at the Margaritaville Hotel on South Padre Island, and it, from our vantage point on a clear day, is absolutely a beautiful, beautiful place to see the launch. If you're going to rent a room here, get one on the south side of the building. You will see a full shot of both launch towers at Starbase and then also the production site. And if you lean to the left just a hair, you can see Massey's off in the distance on the right-hand side. As we get close to 90 minutes, we're going to get into our terminal launch coverage here in just about 7 or 8 minutes, which means we're going to be bringing you more of this, but we're also going to talk some different things about this big, giant rocket. And you can see on your screen right now, it's one of a really neat shot where the vaporizers, you can actually see the ground fog. That's actually coming from the propellant site. I'm going to bring Alex in just a second and talk about that. But EJ, that's coming from the propellant plant, not the propellant plant, but the commodity storage.
The tank farm.
Tank farm. That's the word I was trying to think of. Yeah. And look at it. You can see where the wind is coming through and pushing all of that out. Now, as it vents, right, we're going to start to see several things happen. We'll see a vent come from the tower, the OLM itself, and then we'll see halfway up the tower. So how do they get the fuel from the propellants into the ship, into the booster? Let's talk booster first and then ship.
Okay, so this is a very unconventional way, might I add, of moving propellants into a booster.
Yeah.
Usually, like let's take I don't know, just a conventional route. We'll take the space shuttle. The space shuttle would tank basically hours before they launched, and how they would do it is basically heat up the tanks. You heat up the tanks, create head pressure in the pipe, it moves. It's a very, very simple way of doing it. There's heater coils in these pipes. They heat the pipe up, and you get the propellants moving. Now, SpaceX, because they have some very, very, very interesting design criteria here, meaning that rapid reuse that we keep hearing them talk about, they can't really do that. That takes a little bit of time. SpaceX can't afford to do that. This thing's got to go. To get up and go, it's got to go. So what SpaceX has is actually, there are impellers. If you might be able to see them on the heat exchangers. There are huge liquid impellers that they use to move these propellants very, very quick. Basically, it's a big fuel pump. From what I understand, they look like municipal water pumps or something. I'm not really 100% sure what they are, but these fuel pumps will start moving these propellants through the heat exchangers into the pipe. Because you got to remember, SpaceX needs to do this quick. They need to do it fast. You need to be able to get this rocket fully fueled as quickly as possible so it can get up off the pad and go out and do its thing in space. That's really, really kind of a big deal because SpaceX is trying to go for rapid reusability, right? They're trying to make sure that this thing can be reused over and over again and the fueling isn't a bottleneck. Like, once again, if you cast your mind back to the space shuttle, that thing took hours to fuel. And even then, it went into a top-off before, and then they put the crew on board and go from there. This thing is not like that. This ain't your daddy's space shuttle, Gene. You know what I mean? This thing has got to go quick. So they have these big fluid impellers that move this fuel around. It's really, really cool because, you got to consider, we heard Alex talk about how heavy this thing is. They're moving an amazing amount of propellants into this thing in like an hour. It's pretty crazy.
He said 5,000 tons of propellant.
It's no joke.
That is an amazing amount of fuel. And you see it there on your screen. Some of that gets vented and it makes this haze that comes across. And of course, they'll probably have some drone footage and some cool camera shots of that as it goes through. And then once it gets up to the ship, it's got to go up the tower because the halfway up the tower, you see on the left-hand side of your screen there in the middle, the left-hand side of the launch mount, what you see is what's called the BQD or the booster quick disconnect. And then halfway up the ship, if we can get a shot of that, you'll see the ship quick disconnect. It's pretty much the same thing, except to protect them from the roar of 33 Raptor engines, they protect themselves differently. Talk about how the ship quick disconnect protects itself at launch.
So the ship quick disconnect basically moves out of the way. It's on a hinge. That hinge is actually on the back side of the tower relative to the vehicle. It disconnects and it moves out of the way. It's on a big retraction arm that moves out to the side when the vehicle goes to launch. Obviously, you don't need your fueling paraphernalia lighting on fire when the rocket goes up. You want to get out of the way because if it stays there, you're going to lose it because there's going to be 33 engines coming up right up in its business, right? So the ship quick disconnect actually moves out of the way. That's comparatively like the booster quick disconnect, which is down on the OLM ring at the bottom of the vehicle. They can't really move that out of the way. It's kind of attached. So they have a big metal cover that basically swings into place and covers it from the business end of super heavy, basically frying it into oblivion.
Yeah. And then the ship quick disconnect, it swings out of the way, right? It disconnects, swings out of the way. Yeah, that's what I'm saying.
Yep. Mm-hmm. Yeah. It moves out of the way. But
it doesn't move very fast. It still gets scorched, doesn't it?
Yeah, it's.
I would say yes.
Everything in that general area is gonna get scorched.
Yeah.
Let's be real.
Yeah.
But yeah, it does kind of swing out and out of the way. I mean, you don't need to get it very far from the rocket. Like, if it's sat in that same position, obviously you'd run the risk of hitting it, but it would probably get pretty messed up from those 33 engines. But even like, I don't know, a couple feet out of the way or a couple meters out of the way, right? You can mitigate the damage a lot.
Yeah.
But yeah, that thing swings out to the right and makes sure that it doesn't get hit by the engines.
And let's talk about those engines for a minute.
Sure.
These are full flow stage combustion engines. Tell everybody what that means. What is a full flow stage combustion engine?
So the Raptor engines, it's basically, the key to any rocket is your propulsion. The entire design of the rocket is built around your propulsion. Think like the space shuttle. The space shuttle is built around the space shuttle main engines. Without the main engines on the space shuttle, you're not getting very far. You're not getting anywhere. Right? So the Starship is built around these Raptor engines. Now, these Raptor engines are full flow stage combustion cycles. And we could nerd out here if we really want to. And it depends on how much lung capacity I have here.
Yeah, right.
I'll talk your brain off here. But a really quick and easy way to understand how like a full flow stage combustion cycle works is that you basically have on the side of the engine, you have two jet engines. One of them is designed to run with a lot of methane and a little bit of oxygen. And the other one is designed to run with a lot of liquid oxygen and a little bit of liquid methane. And these two jet engines, they're called pre-burners, right? And those two jet engines basically find their way into the combustion chamber on Raptor, basically where the big explosion happens. You get more fuel and more oxidizer put in there, right? And then you get a gigantically energetic explosion coming out of the bottom. Raptor is, in its main combustion chamber, is capable of 300 bar chamber pressure, which is 300 atmospheres. That's a lot. That's really, really high pressure here. Now, if you think about it, like in terms of jet engines, jet engines have afterburners, right? An afterburner, like a reheat. This is doing the opposite of that because this is upstream from your main ignition, right? So they're called pre-burners. These pre-burners are driven also, they're driving the impellers. They're driving fuel pumps that pump the fuel into the pre-burner. Pre-burner does its thing. Jet engine exhaust, pre-burner engine exhaust goes right into that main combustion chamber. And then you get a lot of freedom coming out the bottom there. You know what I mean? You get a lot of freedom. That's the quick way of saying it. The benefits of a full flow stage combustion cycle is that you can get really, really high chamber pressure. You can get a very, very, very powerful engine from this. But having a very, very powerful engine does have its drawbacks because you're kind of pushing the limits of material science here. Long story short, stuff likes to blow up.
Yeah.
Yep. That's the quick way of saying that.
And we saw that on Flight 7. Things do that. And sometimes they're intentional, sometimes they're not. On your screen right now, you are looking at Starship Super Heavy Booster 15 with Starship 34 on top of it at Tower 1 at Starbase, Texas. And the venting you see underneath that is from the tank farm. And we are about an hour and a half, 1 hour, 29 minutes to the opening of their launch window. And that allows SpaceX some wiggle room when it comes to these test flights. Sometimes they need to recheck something. Sometimes they need to top off something. Maybe a temperature is off, or a valve needs to be opened or closed, or they just go through their checks again methodically. This is a test flight, so they give themselves a window. So if it doesn't launch exactly in 90 minutes, that's okay. That's why in the upper left-hand corner of the screen, you see it says net 1 hour 29 and some change. That means no earlier than, and we do that so we're not giving you a T0 because you know what, they might push it into that window a little bit. Again, this is a test flight, and that is 100% expected for them to do. So let's talk about the status right now. Let's actually talk about Adrian. I'm going to bring you in on this conversation because you're watching the weather, you're watching the ship, you're watching all of this amazing support come in, and thank you guys so much for that. But right now, the status of this ship is we start to expect things to happen very rapidly as we get closer to that eventual T0 for this rocket.
Absolutely. I'm basically in a like field of monitors here at this point that is just in front of me, and I'm trying to spot anything that is going on. We are definitely inside of the window for where we would expect tower/pad vent, which, again, Alex said earlier, they have a bit of a wiggle room. They also have a quick way to chill that down. There's like a quick path and a slower path to chill down. But we are getting there. It is all so far still looking good from what we can tell. I will not say anything about the weather I have been looking at because I know there's a person coming up way more qualified than me to talk about this, so I'm not going there. But yeah, we are looking quite at a quite active tank farm, which honestly is good. Like if at this point, if we arrived at T-minus 90 minutes and the tank farm would be dead silent, that would have been bad news. But we're not there. That's the good one here. And if you don't mind, I also quickly run some support here because I'm having some ones I really want to hit here. Starting with probably one of the hardest questions I've ever seen. Longdis with a $100 super chat. Thank you so much first for that. And now here's the very hard question. What is your favorite space-oriented game? And
oh my.
I have the advantage of having thinking about this for the last 5 minutes. And I've come up with, I am only able to say the Mass Effect trilogy and Faster Than Light. That's my answer.
You want to go around the room? You want to go around the room?
Yeah.
EJ.
I think, EJ, you have to, like...
I like Star Wars X-Wing versus TIE Fighter. No,
Hey.
just kidding. No, that is a good game. That is a good game. To be fair, good game. Kerbal 1 is my number one.
Yeah.
Guys, that's Kerbal 1 is the best.
That's
I
where
love that.
that's where I was
video
going to
game.
go.
I do
There's
stream
more
it
like
over on
Kerbal
Twitch
1?
from time to time. Oh yeah.
Yeah, I played
Yeah,
some
right.
Star Trek, played almost every Star Trek game there is, but yeah, when it comes to rocketry and space flight and physics and orbital dynamics and all that, Kerbal is just it's a fantastic game. Alex, what were you saying?
I was making the joke that EJ said Kerbal 1. I was like, there's more than one. Anyways,
Yeah,
No, there's not. No, there isn't.
there is there is not. Okay. Somebody actually mentioned this in chat. There's this game, Ratchet and Clank, I think it is. I love that as a kid. Shout out to whoever said that in chat. I already lost it, but I loved that game when I was a kid. I've played Orbiter Flight Simulator as well. I like that. Apart from it's more like an advanced version of Kerbal, and you have real life rockets, although you cannot play with them. Unfortunately, you cannot do mods stuff and and build your own rocket, but you can fly real rockets, which is nice. Yeah.
If we're talking about games when we were kids, I'm going to date myself because I go back to the Moon Patrol days. You guys are way too young to know what Moon Patrol is. That was a lot of fun. Come on, chat. Anybody my age in Moon Patrol time? Yes, thank you. Galaga. Galaga is absolutely my favorite game, but we're getting off topic. We're going to talk about this rocket that we actually can't see out here. Go ahead, Adrian.
Let's go back to Starship.
I have something very on topic I'm about to bring up here, and that is that the roadblock, which was still at the closer checkpoint, has just started to move back to the further out roadblock, which usually they do. There you can see it. It's completely empty, and that does not mean the road is open. The road is absolutely not open. What they are doing is they're moving it further back because they are about to commence into the deep stages of what will end up prop loading. So even the police the sheriffs will take a bit of a further away position here.
And that's all good news going toward an eventual T0. We are about an hour and 24 minutes from the opening of the launch window. So you start to see those things that kind of give us indicators that SpaceX is proceeding with the launch. And we are going to get a weather update here in just a minute. But one of the things that we look for as we look back at Starship 34 up there on the tower are these vents. We'll start to see venting from different places. And they kind of give us an indication of where they are within their countdown and where in that window SpaceX is looking to launch the ship. Alex, you wanted to say something about that?
No, I was agreeing with you that you are indeed correct with
and I got something
the
right.
vents and everything.
EJ,
Congratulations.
I got something right.
Look at you.
Hey, I intercede when I think something is off, right? So I also need to say something when I agree with you.
There's a great shot of the tower on the left there. That's a really nice close-up shot. You can see the piping on the left side. You'll see that start to get white when they start to move those propellants up and down.
There's
and
a,
also, guys,
there's a vent there.
Yeah, Alex. I mean, that's cool. I'm looking at the monitor up close, guys. I always wanted to try to tell people the scale of this. Now, obviously, the best way is to come down here and see it. But if you want to understand the scale, and you look at the left side of your screen, right? We got a shot of the tower there. Look at the stairs. Look at the staircase. Those are flights of stairs right there. That should tell you how big this thing actually is. It is a monster of a piece of equipment here. The rocket and the tower. I would say, look at those stairs. From those stairs, you can really kind of get the scale. You can get how big one of these things is. Just look at the flights of stairs. They're right there. Yeah. Crazy.
Can you imagine the elevator breaks and you got to go up those stairs?
Oh, no.
No, that's a lot of stairs.
Hard to pass.
I mean, you're at work, so if your job is to go up that, then your job is to go up that. Later on, we are going to talk about that, the size of the ship. We talked about the propellant and about 5,000 tons of fuel, Alex, that approximately go into it. But we are going to show you some comparisons later on about how tall this ship is. And remember, this is block 2 of the ship, block 1 of the booster. And I wanted to talk about the future of the booster. Alex, I'll bring you into this conversation while we're waiting to see some of these events get more active. When they added the hot stage ring, EJ and I talked about the hot stage ring and why they did that. They're going to integrate that. The plan is to integrate that on future versions of. And by the way, for those of you who don't know, this is a 2-stage vehicle. The upper stage is called the Starship. The booster down at the bottom, we call that the super heavy booster. So the at the top of the ship that you're seeing now, that is the Block 2, or the second variation of the ship, which is a little taller, a little more fuel in there. And then down at the bottom is the original Block 1, not the original Block 1, but one of the latest version of the Block 1. And Alex, as we go through and into Block 2, potentially Block 3 and beyond, what changes are we looking for as we go forward?
Well, one of the main changes that we're going to see is they're going to stretch both vehicles, right? Block 2 of the ship is already a ring taller, and it contains 25% more propellant on board. That is not just because of the extra ring, but also because of other optimizations in the tank volume, and also shortening the size of the payload bay section. It doesn't mean that there's less payload volume available, because they also did optimizations on the nose cone area, so they can use more of the nose cone now as well. Many of the other things that we're going to see is optimizations for reuse. So, for example, there's not going to be all of those very pesky engine shielding and everything that they needed to install. There's going to be a lot of reductions in mass. There's going to be a lot of things that are going to be improved in that area. But as you mentioned, one of the things that they're going to do is they're going to integrate that structure of the hot staging interface. So instead of being a separate ring that they need to install, it's going to be just part of the vehicle structure of the booster. In the renders that SpaceX published last year, it looked more like the Soyuz hot staging interface, right? Which is like a truss kind of pipe section that just leaves a lot of room for that exhaust to escape. One of the things that we don't know, though, is how are they going to address things as simple as, well, what's going to happen with the top of the booster, right? Because it's going to get blasted by those engines. Sure, you have the vents and everything, but you still need some kind of protection. So we don't know how that is going to look like. We're definitely on the lookout for any sort of Block 2 booster material out there at the production site. Always peering through those windows on the Star Factory, trying to see if we can spot something along those lines. So far, nothing that really screams, "Ooh, I am an interstage interface" or something like that, right? Like there's nothing as such right now that we've seen, but we'll be keeping an eye, and we'll see how that looks like, from render to actual metal physical thing.
And if you want to keep up with all of the goings on at Starbase with the Starship program, you can watch Starbase Live, one of our 3 live cameras here at NSF. We also have Space Coast Live if you're interested in those launches from the Cape, and also McGregor Live when they do rocket testing. You can tune into those on YouTube. And especially here at Starbase, there are folks in the field with their cameras, and they come out here several times a day. We do Starbase updates. And we have what we call dailies, but they're usually a couple times a week, where we give you the updates in snippet form, and it's voiceover, or you can just listen to the ambient noise. And earlier in some of the shots, you could hear in the background some of the ambient noises, the pressure being released and things like that. So we listen for those. We watch specific things on the video, but you can keep up with all of that at Starbase Live. And also every week at Friday, you can watch This Week in Spaceflight here at NSF, hosted by our own Alicia Siegel, who gives you all the rundown of what happened here at Starbase, also everything across space and the launches for the week. So be sure to check out all of those on the playlist from NSF, because there are a lot of really talented people in the background and on the ground bringing these shots to you. This is a shot looking from the backside of the tower, and you can see the ship there and the quick disconnect on the right-hand side and those chopsticks. Now let's focus in on the chopsticks for just a second. On top of the chopsticks, there's these little bumpers that come down, right? And they've worked on those. They figured these things out. And when we saw in past flights, when the booster came down to be caught, it actually doesn't land on the chopsticks. That's what we call those arms themselves, but it hits those bumpers. Now, if it's under its own power and it's kind of, I don't want to say hovering because it's close, why do we need those bumpers?
So those bumpers are there to dissipate the load. You don't want to shock load the chopsticks because they'll snap right off. Basically, when the engine shuts down, the full weight of the booster is going to be on those chopsticks. And if you can find a way to not do that quickly, right, you're going to not snap your chopsticks off, right? So those kind of catch rails, those bumpers are up there to basically dampen out the the load that's exerted from the weight of the booster from the engine shutting off. Because obviously, the rocket engine's firing. You said it's not hovering. It's kind of not. But the rocket engine's firing. The force from getting put out from that rocket engine is enough to, keep the booster basically hovering, right? I mean, it's not hovering. It gets close, but it's not. But basically, if they just, you got to shut the rocket engine off quick, right? It has to be shut off fast, right? You can't you could throttle down the rocket engine, but you can't like get it down to like 2% throttle. This isn't KSP as much as I want it to be, right? So what you do with these things, what they do is because you have to shut that rocket engine off fast. You have to find a way to not just have the full force of that booster just push right down on those chopsticks. So the bumper pads that are up there are there to dampen out the force. They're basically like a shock absorber to prevent all of the weight from super heavy all at the same time being exerted on the chopsticks there. Now, keep in mind, like the chopsticks are hydraulically actuated, right? So basically, when super heavy lands on these things, they're going to want to push out. They want to push out and away. So it's not just about straight up loading the chopsticks. It's about making sure they don't shoot out to the sides. And those hydraulics are under insane amounts of pressure. Like, I don't know if you've seen the hydraulic actuators. They're like the size of my truck to move those chopsticks back and forth. When super heavy lands on these things, you got to dampen out the force. And you got to dampen out up and down. You also got to dampen out left and right. So those bumpers actually kind of move a little bit out. Not a little bit out. It's kind of the actuation mechanism kind of makes them move like down-ish a bit. Like they don't really move out too much. But once again, they're there to basically make sure those sticks don't snap off. And they're there to make sure the sticks don't push out either.
And once it captures the super heavy booster, it comes in between and kind of catches them on the little pins that stick out from the side of the booster, which you can see on some of our closer cameras. You can see the pins that stick out on the side of the super heavy booster, which of course they're testing similar pins on Starship on this flight for re-entry purposes. They're not structural. We keep saying that. On the next one, they should be structural if they decide to go for a launch. But then what they do is they safe the booster. And Alex, you want to answer that one? What that looks like when a booster comes back, it gets caught by the tower, and then it goes through that process where they safe the booster. What exactly are they doing to make that vehicle safe, and then they can put it back down on the launch mount?
Yeah, one of the things that they do, for example, is so as you mentioned, they put it back on the launch mount, then they connect the booster quick disconnect, right? It's kind of a funny reference that I just said connect quick disconnect, but they do. They connect those umbilicals to the booster, and they are able to sort of drain back whatever is left inside of the vehicle, right? And that is a good thing because then they are able to get. For example, even the COPVs that store the high pressure gases and whatnot, they can drain them back and things like that. They can save the vehicle. One of the other things that they do, well, after it's already detanked and everything and the pad is open, they also remove the flight termination system charges, which they should be disabled electronically because they have once it goes through re-entry, you can hear the call out very clearly on their stream that they are, the FTS is being saved, right? So it's electronically saved, but you still need the physical assurance that it's not going to blow up now as you handle the booster. So you need to remove those charges. That's what they did last time around, and so they get rid of all of that.
We are currently 1 hour, 12 minutes, 13 minutes if you don't count the seconds, to the opening of the launch window. And I want to talk a little bit about that. I talked about it earlier, why they do that launch window, why it's not just an instantaneous, okay, we know what time we go. There's a lot of things going on in the background. Every time they launch one of these ships, it's basically a new ship. It might look the same as the last one, but it has so many different modifications that they change their checklists and their processes to go to launch almost every time. They're trying to shave a few seconds here. They're trying to verify a system there. And when they get to that point where they feel like, okay, guys, we've done this enough, we've got it down as slim as it can be, then they'll move to an operational phase. So it's very common to see a window open and then push the launch deeper into the window. So we're not overly concerned right now. We are still over an hour away from the opening of the window, and then the window itself is about an hour, and we'll be looking for very specific things to happen in that timeline, and then we'll bring that timeline up and talk to you about it as we get closer. We're getting some more weather information that's coming in, and we'll bring Adam in here pretty soon. Not right now, but we'll talk to him about the weather. But I can't read what he keeps posting. He's posting some things about winds and lower level winds and things like that. And we talk about wind shear. And EJ, I'm going to bring you actually in on this conversation. We'll try to get Adam to talk about what's going on, and we can see the fog. Right, we're not outside. We can't feel the wind. But when this vehicle launches, remember, this is a flying vehicle, so it gets all kinds of forces put on it during launch. What are those wind shears that we look for that the vehicle just can't really handle? I know you don't know the tolerances, but I mean, I'm talking about the science of wind shear almost.
Okay, so obviously you don't want to launch the rocket when it's too windy, right? You don't want to. It could actually blow it off course. That's absolutely a thing. If you have a rocket and you launch it when it's too windy, and this is kind of the reason why rockets have wind conditions, right? For instance, say the rocket can't steer. It can't steer. The thrust vector control systems on your rocket wouldn't be able to compensate for high wind. It'll blow it off course. Your control systems can't compensate for the wind. Well, guess what? The wind will put you wherever you're going to go. You're at the mercy of it, right? That's why rockets do have limits in the first place, right? So you have to worry about that happening down here near the surface. You have to worry about that happening up in the upper level winds, up in the upper parts of the atmosphere. Now, on top of all that, and once again, Adam could probably explain this better than I can. This is the cliff notes, right? It's not just the wind down here. It's not just the wind up there. It's the difference and the direction, right? The direction really makes a difference. If the wind is blowing east down here and it's blowing west up there, rockets don't generally like that because you're shifting the loads on the vehicle really, really quick. You got to remember, these upper level winds can get 100 miles an hour, 200 miles an hour, no problem. There's lower pressure up there. The air goes way faster, right? You get a lot down here. It's kind of a soupy atmosphere, to make another Kerbal reference right there, right? You got a kind of soupy atmosphere, like the wind. I mean, we can get pretty good sustained winds down here from like a hurricane or something, but generally, I mean, you're not launching a rocket in a hurricane, right? It's up there, the winds go a lot faster. And it's about the difference between up there and down here, right? If there's a big difference, you're going to have a big problem. And once again, the direction too, big deal. I mean, I want to be very clear. Adam can explain this better.
And he will.
Way better than me. Yeah. And he will. I just hope that when he says it, it's like, oh, EJ was wrong about this. I mean, he might. It's possible. But Adam can explain this better. But basically, it's the difference in winds. If you are launching a rocket and there's no wind down here and there's wind up there, you're running into what's called vertical wind shear. Once again, the change. And that breaks things. That breaks things really, really easily. Like you're putting rockets under unnecessary load at that point. And that's why, you know what I was going to say, that's why we see some rockets launch the next day. No, I am not saying the S word. I'm not saying that. But that's why you do see some rockets just wait another day, because it might be nicer tomorrow. But it doesn't look too bad today. It's just very froggy.
Yeah, and that fog is making it difficult for us to see what's going on from our perspective. But we have cameras a lot closer. Alex, I'm going to bring you in on this one. And some of those cameras are showing us some other venting. Why don't you talk about what's going on?
Yeah, we have tower vent already underway. We are watching closely for the OLM vent, which should be next. Like it's usually within a minute or two of the tower vent, and that's the start of the chill down process. We've seen a lot of that venting on the tank farm. Now the lines that go from the tank farm out to the launch mount and the launch tower are being chilled down. I'm already seeing some of the frost on some of the propellant lines on the OLM, so maybe we're gonna get that OLM vent very, very soon. And so there you can see that tower vent already ongoing. That's gases oxygen leaving the tower there as they flow that liquid oxygen through the line up to the tower and getting all of that. Of course, they're also running liquid methane, but the liquid methane cannot be vented. So there's a return line that sort of comes back to the tank farm, and that's why we don't see that venting going on there. That's why this is for liquid oxygen. And so one of the other things that I am on the lookout for, though, is the timing. So this happened around T-minus 1 hour and 20 minutes for Flight 7. They're still optimizing the load of the vehicle, which also means optimizing all of these chill down process. Does this mean, because we are obviously not T-minus 1 hour 20 minutes, we're a little bit further into the countdown than that. Does that mean we're going to get a T0 a little bit into the window? Perhaps, we're not sure, right? But if it is, it's not by that much, because as I was saying before, it's only like maybe 10 minutes, 12 minutes, 13-minute time frame that we're seeing this change, and that could just come down to them optimizing the timelines and optimizing the processes. But if we do see, again, that difference is just of mere, 10 minutes or so, they will have plenty of margin there. That window runs for 60 minutes, 1 hour long, right? So if it's just that, those 10 minutes or so of leeway that we've seen of difference compared to Flight 7, then they will have plenty of window. Of course, we're waiting on SpaceX, because one of the things that should have happened about 10 minutes ago, T-minus 1 hour and 15 minutes, the flight director executes that go, no-go poll sequence for propellant load. And so that is one of those things that SpaceX will need to confirm. I'm actually getting notifications. I think it's Chris B tweeting on our social media channels. But one of those things that I'm going to be also looking at is whether SpaceX confirms that or not. Usually they do. So I'm going to be on the lookout for that. I'm also going to keep watching all of our cameras and all of our feeds and everything for any more updates. But we're getting very close to that propellant load.
And that's good news. As they start to chill those lines down, we can kind of gauge now things are moving and still moving toward a potential launch here in just, I guess, over an hour and a half or so. We'll know more when we start to see, and we'll talk about that timeline in just a little bit. We're trying to get Adam, who's looking at the weather every second. He's probably getting the latest updates for us right now. So when he's available, we'll go to him. But Adrian, I want to come to you because it's been a while since we've gone through and thanked so many people that are generously helping us bring this coverage of Starship Flight 8. So why don't we thank a bunch of folks?
I will absolutely do that. I will quickly acknowledge the fact that the OLM vent has started. So to quickly wrap that up, the booster chill down has also started now. The booster system chill down, not the system chill down of the booster itself. And after that, I will thank some people here, starting with Chris Waiters, who give a $50 super chat here. With a message I will not fully read, but that shouts excitement for the launch today. We also have John James with gifting 10 Red Team memberships. Thank you so much for that. We have another 5 Red Team memberships from Go Flyer here. Thank you so much for that. Sean Flake with a $20 super chat saying that Starship Flight 8, you're cleared to the Western Australian coast as filled, and a bunch of others. I think this is a flight report, right? What you get from towers when you fly planes. If I'm fully correct.
Flight level 2300. Wow, that's quite high up.
I mean, it is probably quite true, right? So
I will have to check because yeah.
Thank you so much for that as well. We have Oweko with a super chat just saying good reporting. Well, thank you. Tactical Penguin with a super chat here saying, EJ, it ain't EJ quote, it ain't got no gas in it.
Ain't got no gas in it.
Hope you all got Jack's rear door working again. Thanks for the tank of gas.
Yeah. That's an inside story. We're not even going to go down that road.
Maybe later.
Okay, I will. So I will ask about the story after the stream, correct?
Yeah, we will. We can talk about that later.
Cool, thank you. David Ferguson with a super chat. Do you know if there's an electrical or communications connection between ship and booster? Alex, is there a direct connection line between ship and booster?
Unfortunately, we have not seen that yet. If there is, it doesn't seem that there might be one, or at least it's not very obvious. On Falcon 9 there is. There's even connections between the side boosters on Falcon Heavy. But so far we have not seen any direct connections between booster and ship.
Excellent questions, and thank you guys so much again. We can't do this without your support, so thank you for all of those tips and super chats and going out to our store and picking up shirts like we're wearing right now. All of it helps us, and it helps us with these cameras. Now, I will tell you that all of this money, the vast majority, they go out to the cameras. We're always upgrading cameras and connections and internet connections and things like that, so we can get just that much closer just that much more zoom, that better connection, and better quality video for you. And it's all because of you guys supporting us. On your screen right now, you can see obviously the tower vent. That is a big deal. That lower right-hand shot's actually really cool. What are we seeing, EJ? Or I might go to Alex since this is a propellant question. What are we seeing in that right-hand middle screen? Are those subchillers, condensers, valves? What propellers? What are we seeing there?
Those, so the black things on the right hand side, that's for Pad B. Those are part of the pump assemblies for Pad B. Not active today. That's going to be for Pad B, right? But in the future they'll be active, and it's not fully installed yet either. So we're not going to see any activity from that today. But as you can see, there's a bunch of other activity going on. There was an OLM there just a couple of minutes ago. I was actually going to point out, you can see the return line of the methane being frosty and whatnot. But yeah, the tank farm activity is blocked in that view right now. Of course, we have many other cameras, so thankfully those are not being blocked, and you can see lots of activity from the OLM, as you can see there from that south view. And yeah, that OLM vent going strong. We're gonna get much more activity from that. Like, that vent becomes even more and more active as we count down to that propellant load. That vent will disappear at the time of liquid oxygen load on the booster, because that's, again, as I was saying before, it's related to the liquid oxygen venting, that chill down of that liquid oxygen line. So when the vent goes away, that's our sign that the liquid oxygen is being loaded onto the booster. For the tower, we're going to see a pause. So at some point, it's going to disappear. There's no need to be panicking or anything like that. Then it'll return. And once it returns, it becomes a lot more active. We see sort of like it's a cape coming out of that tower. It's amazing. It looks like a superhero kind of thing with the arms and everything, and the cape behind it, right? And once that huge vent essentially goes off and disappears, that's when we're going to get our sign that liquid oxygen will be loaded onto the ship. So that's more or less the behavior of these vents that we've already seen in the past few launches.
And, it's frustrating for us because we look out the window here from the Margaritaville Resort and we see the fog. We can't actually see it. So thank you, NSF, for all these great camera views and these close-up cameras. So we're going to talk about the weather because we're watching it just like you're watching it on YouTube and also on Popular Science Channel. We're watching it the same way because we look out the window. All we see is a gray, foggy sky. And we're going to bring in our NSF meteorologist who's going to talk us through the current weather for this Starship Flight 8, Adam Suker. Adam, come on in.
Hi, yes. Everybody wants to know what the weather's going to be doing. We're just under, an hour away. So one thing that we have been watching very closely is an area of clouds that has moved in. I was explaining that earlier, that, we'd probably have around 70% cloud coverage around the 5:30 launch window. I was guessing, if they were right at the top of the launch window there. Now, with this cloud graphic, if you notice, if you look just south there and just into the Gulf, you can see there is clearing that is slowly working its way up towards the South Texas region. The only thing is that clearing, it looks nice out there right now where it's trying to clear up a little bit, but there's a little bit thicker clouds that's going to come in right about the start window around 5:30. If they were to hold off a little bit longer, say we try to get a little closer to the last of the window, closer to that 6:30 mark, we could actually see that clearing come through. So depending on the exact time of launch will depend on how the clouds are going to act for us. So if it's at the start of the window, expect to see clouds, those kind of mid-layer clouds that are come over. If we're toward the end of the window, we could actually see some clearing come up just in time. Something the models didn't pick up very well on, except for that 5:30 window. We were expecting to see some cloud coverage. So now everybody's been talking too about the foggy haze look. So what that is, if you can go to the next graphic that I posted. So basically what's happening is where I have a little, I believe it's a red arrow. Yes, the red arrow that's pointing. That's a temperature inversion. So basically that's showing a temperature rising as you go up just a little above 1 kilometer, about 4,000 feet up. That right there is a temperature inversion. So that is heat aloft, and that heat kind of suppresses a lot of stuff, and it also will suppress sound to make sound waves a little bit louder at the surface. With that being said, with the southeast wind coming off the Gulf, you're getting like that sea mist and a lot of particulates that are staying trapped, down in that first couple thousand feet. So you're getting that real hazy, foggy look. And because of that and those mid-layer clouds that are right there at that same level, you're getting that visibility that's not very good unless you're closer. If you were more inland and not looking straight down the ocean, so say someone was probably looking from basically straight inland and not perpendicular with the ocean, it would actually be a little bit clearer than trying to look down the ocean where you got all that sea mist kind of coming in and that salt. With the winds, though, that's one biggest watch item that we've been watching. So what I have circled there in blue, think of that as going up from the surface and the rockets going upwards as you go up on the graphic. You see that the winds start off, it's pointing southeast. That means the winds are coming out of the southeast. And then as you go up, they start turning westward. Well, that's called directional shear. Well, that lowest level is very important for the ship, the rocket ship, as it's launching. You don't want these winds headed all different directions as it's going up in a short amount of time. So it takes a lot of deviation to keep going up straight with that kind of winds. And you got to think about if booster returns, it's also going to have to come back down into those winds and get pushed all around. So there is a limit, and they just got done. SpaceX launched 2 weather balloons because, like I was saying earlier today, the forecast models are just a model. It's a guess of what the winds can be. They launched 2 weather balloons. Right now, their meteorologists are going over the fine line because I have to admit, the surface winds have been a few miles an hour higher than we originally anticipated. They've actually blown up to 30 miles an hour now at some of the reporting sites. So now their meteorologists are gathering this data. They're making sure that this can still be within safe levels before they give that go for weather. So this is still going to be, it could be right there close to the limit or just a little bit below. So once their meteorologists grab all that data, they'll be able to really make that determination whether or not is it going to be safe enough to launch wind criteria that they currently have. Back to y'all for any questions.
Well, we have a lot of questions, but I think you covered them all with that succinct update. Adam Suker, thank you so much. NSF meteorologist keeping his eyes on the weather for us. And on your screen, you can see the tower vent in the lower right-hand corner, and then you can see what we call the OLM vent in that middle shot. A close-up on the left there has been vented out. It's with the vapors, and then upper right-hand corner, you see the Starship getting ready for potentially its 8th test flight. Now, I see some things in the YouTube chat, and I appreciate everybody putting some stuff in there. The counter in the upper left-hand corner is not an official T0. I want to stress this, that NET stands for no earlier than or not earlier than. So we are waiting for an official T0, and we kind of know when things happen in the countdown. So please, when you look at that clock, that is the opening of the launch window. That is not rocket go boom, rocket go space. That is the opening of the launch window, and folks in the control room are going through their final checks. They're going through their go, no-goes. They're looking at the rocket. They're looking at all the sensors that are built into it, and they're making sure that everything is within their flight tolerances, as Adam said. They're also looking at the weather. They're looking at what's going to happen, at 1,000 feet, 10,000 feet, etc. They're also looking at the weather in the Indian Ocean when this ship is supposed to come back into re-entry through peak heating and then splash down at a very, very precise point in the Indian Ocean. And let's talk about that, EJ. Let's talk about that re-entry and then that landing. Why do they have to be so precise? Obviously, this is a test flight, so the reason for this is they're pulling data. They want as much data from this. Why are they trying to get the Starship on its flip and burn maneuver when it comes in? Why so precise?
Well, the short answer is that they're going to eventually try to land one of these things, Gene. They got to bring it back to the chopsticks. So if it's not precise enough to get near the chopsticks, when you're trying to not land near the chopsticks, like on these test flights, if they can't get it precise enough to get the fidelity that they need to get that thing landed on a future flight, you're going to have some problems. Something that gets thrown around in the aerospace industry a lot is test as you fly. So basically just test as you fly, right?
In the Army, we used to say train like you fight.
Train like you fight. Yeah, there you go. Right. Same thing. Every one of these landings that they do with these Starships when it comes down off the coast of Western Australia, every one of these is a practice. It's a practice for when they go to do the real thing. So when they seemingly do go to do, or not seemingly, when they do go to do the real thing, hopefully we see a ship catch on the next flight. I mean, it doesn't know. It really kind of is contingent on how good this one goes, right? When we do see one happening in the future, they'll already have some data on it. They'll already know how to do it. We saw the exact same thing happen with the booster during Flight 5. Flight 4 did the water landing, right? And that water landing was basically, there were fake catch arms out here. At least the booster thought there were catch arms out there. And it landed with sub-centimeter precision per SpaceX. And then when Flight 5 came around, they got it. That thing got caught on the first try, seemingly on the first try. Or was it? Right? It wasn't, right? They were testing it. So these ships, when they do these missions, these suborbital missions, they got to come down precisely, because that's all paving the way for when they eventually go do a ship catch. Hopefully on the next flight. Hopefully, could be as early as that. We don't know. Once again, it depends on how good this flight is, but we'll see.
Yeah, and we will see. Hopefully, here at inside that 1 hour window that opens up in just right at 51 minutes. You know, something that we do here at NSF is when you support us, we love the fact that you get something in return. So when you help us put a new camera out, or have a photographer, or have these live broadcasts where all of this stuff costs money, that's support that you give us that comes back to you. But also, we have a store, and we love you're wearing a Flight 7 shirt. I'm wearing one of our Thrust collection shirts, and there on your screen you can go out to shop.nasaspaceflight.com, and you can check out all of the shirts that are available, the hoodies. And right now, you can pre-order your Flight 8 patch. And as Adrian said earlier today, they are about halfway gone already. And they were announced last night when the full stack happened. Wow. Isn't that incredible?
That's pretty crazy.
Thank you guys so much for going out there and helping us at shop.nasaspaceflight.com. You can get stickers, you can get the patches, you can get the shirt, the hoodies, and something new. Look at that beautiful patch on the screen right now. That's amazing. One of the things that just came out as well last week was the tote bag that has the pattern of the thermal protection tiles on it. So if you want, we got to come up with a good name, like thermal tote bag or tote protection system or something. What's a good name for the tote bag? I'm gonna send it to Adrian here in a second.
Fully reusable, rapidly reusable grocery bag.
Oh, a tote bag. I like that. Yeah. Rapidly reusable tote bag.
Rapidly reusable.
I'm renaming that. I'm renaming that right now. Starship DPS.
Yes.
Fully reusable.
Nice.
Real time. Happening in real time.
You heard it here first.
But something else that helps us out. Something else that helps us out, doesn't cost anything. It's just hit the thumbs up. Tell your friends, tell your neighbors. We love what we do. We are not a big media organization, as you hear Doss or say all the time. We're just a group of friends that love doing this. And this is we just come and we nerd out and we have a good time doing it. And I mean, you flew in, I drove in. We have people coming in from all over. They drive in with their cameras. I was talking with Jack the other day about some of the cameras that he rents with his own money so that he can do this. And that's really what NSF is. It's a group of friends that bring you these launches from literally around the world. So thank you for supporting us. And we love that you're here. Coming into our flight, potential Flight 8 launch here. The window opens in about 48 minutes. And I forgot, what was the other thing I was going to talk about? Help me out here, EJ. I had it in my head and then it went away. Oh, that's right. Our socials. That's what I was going to talk about.
Yeah, you're welcome. I helped.
Thank you. I was like, what was it? I had it in my head. Thank you. All of our socials are available as well. Follow us on Facebook, on Instagram, on X, on what's the blue sky? What's it called? Blue sky?
It's called Blue Sky.
Okay, I got that one. Yeah, we are everywhere, and all of that support helps us as well. So thank you very much. I got a lot of things going on as we try to keep going here. Hey, Alex, I'm gonna bring you in. How long does that OLM vent normally take?
Well, not much, but I have breaking news.
Oh, go.
Not directly related to today's launch, but oh man, we're getting some juicy information from SpaceX on future Starship operations
Look at that.
At the Space Coast. That's a render of the Gigabay at Roberts Road in the Kennedy Space Center. You know, if you're a regular of the channel here at NSF and you watch our Space Coast updates and whatnot, those flyovers that we do, you may know a bunch of these things. The Gigabay in Florida will stand 380 feet tall and provide approximately 46.5 million cubic feet of interior processing space with 815,000 square feet of workspace, including ground level, elevated platform work areas, and a work and meeting space on the top top floor. Giga Bay will be able to support Starship and Super Heavy vehicles up to 81 meters tall and will provide 24 work cells for integration and refurbishment work, along with cranes capable of lifting up to 400 US tons. Compared to the Mega Bay facilities in Starbase, currently SpaceX's largest stacking and integration buildings, Giga Bay provides more than 11 times the square footage for workspace, 19 additional work cells, and more than twice the crane lifting capacity. This is going to be a huge project that they're going to be building out at the Space Coast, and quite the timing here from SpaceX as we're readying for Flight 8 of Starship. And they say on this update, they want to have online that Launch Complex 39A pad, that Starship pad there at that historic launch site where humans went first to the moon out from Earth. And, you know, that's going to be quite an amazing development. There's a lot of more updates here as well. For example, work on this Giga Bay has already begun, and the facility is targeted for completion by the end of 2026. So we have sort of a bit of a timeline there for that Giga Bay. We also have a confirmation as well. Giga Bay at Starbase in Texas, they're also going to be building that next to the Starship Star Factory manufacturing facility. I'm like reading it right now as I go along here with this update. As we work to complete the Giga Bay in Florida, we are designing and planning for a co-located manufacturing facility similar to the Star Factory in Texas to enable production of Starships in Florida. To enable initial Starship flights from Florida while our Space Coast Starship manufacturing, integration, and refurbishment facilities are being completed, we will first transport completed Super Heavy boosters and Starship upper stages ships from Starbase via barge to build up a Starship fleet in Florida. So essentially, they're going to take completed boosters and second stages out from Starbase, barge them over to the Space Coast, and be able to launch from there while they're building up their production capability there in the Space Coast in Florida. And so it's amazing. They're talking about, to support initial Starship launches from Florida, blah, blah, blah. They're launching a Starship launch and catch site at LC-39A at the Kennedy Space Center. It will include all of the learning from Starship's 2 pads in Starbase. They are obviously talking about the launch tower at LC-39A in 2022. If you've been follower of the channel, you've seen that, right? Because we've been covering all of that progress. In the coming months, teams will build and install the pad's deflector system, which provides cooling and sound suppression water during Starship launches and catches. This new deflector will be nearly identical to the one being installed to support the second launch pad at Starbase. The one with a flame diverter and the big launch mount. Yes, Adrian? I see
Alex,
you.
I need to Alex you.
Yeah, sure.
We got an update. We got an update from SpaceX that the Starship team is go for propellant load today, and they are now targeting 15 minutes into the window, which is 5:45 p.m. Central Time. So that is, and now this is no longer a net. This is now a T0, 58 minutes, 33 seconds from now.
Excellent. And that's the information we were looking at. Alex, is there anything more to add about the Giga Bay, the Giga Factory, the amazing news coming from Florida?
Just the end of it, they say that pending completion of environmental reviews, SpaceX intends to conduct Starship's first Florida launch from LC-39A in late 2025. That's so amazing because it's like
that's this
year. That's this year. I did a joke the other day about some of the timelines. It's like, I don't think they realize where that date is in the calendar. Same thing with this. We'll see about late 2025. I think it's more likely 2026, but hey, SpaceX proved me wrong, right? As I usually say. They're obviously talking about Slick 37, Space Launch Complex 37 at the at the Cape Canaveral Space Force Station. SpaceX has been given a limited right of entry for Slick 37 in support of conducting further due diligence of the site in order to move forward with the environmental impact study led by the Department of the Air Force for Starship and Super Heavy operations at the Cape Canaveral Space Force Station. Slick 37 was built in the late 1950s and early 1960s. NASA used the pad from 1964 to 1968 for testing of the Saturn I and Saturn 1B rockets as part of the Apollo program. From 2000 and 2024, the pad was used for the Delta IV rocket. So yeah, it's another historic launch site, of course. Saturn I, Saturn 1B, and of course the Orange Queen, I guess, if you don't count SLS, which is the Delta IV rocket, and the Delta IV Heavy rocket as well, just had its last launch just last year, essentially.
That is amazing news, Alex. And obviously, we are all looking forward to the amazing things that are going to happen from Florida, but also here in the next 56 minutes. And what I want to see in chat right now, I want to see some people getting crazy. Tell us where you're coming from and that you're ready to see Flight 8 as we are go for prop load. And it is time. It is time for this rocket to go to space here in just a few minutes. And we are talking about a T0 that is inside their window at 5:45 Central Time, and which is coming up, I guess, in about 50 minutes. We need to fix that clock right there in front of us and also put that clock in the upper right-hand corner so everybody can see that beautiful T0. 54 minutes, and we are going for propellant load. Thank you guys for blasting in chat where you're coming from. We looked all around the world, and we've got you here with us in Starbase live to bring you this test flight of Starship. Now, Alex, I want to come to you. Let's talk about real quick, when we go for propellant load, I asked you earlier, how long does it usually take to load this vehicle?
Yeah, the first thing that we're going to have is that ship liquid oxygen load underway, which it's essentially a T-minus 46 minutes. Right now, you can see the tower vent has disappeared. It'll come back, and once it comes back, then it'll become a lot more active, and then it'll go away, this time for real. And so you can see some of those lines already frosty. Look at that. Some of that condensation, those umbilicals out to the ship. And essentially in 7 minutes, that's when we're going to get into that liquid oxygen load on the ship. Then about 3 minutes later, we're going to have ship fuel, T-minus 41 and 22, we're going to have booster fuel load. And then the last thing that gets loaded is the liquid oxygen on the booster at T-minus 35 minutes and 35 seconds. So we'll keep an eye on all of the things. Of course, now we have that go for propellant load confirmed by SpaceX. So all things considered, it should be really pretty much on time.
So you could hear some of those venting sounds in the background there. And one of the things that we talk about is the scale of this rocket, EJ. We zoomed in on the tower earlier, and you were talking about, that's a staircase, those are stairs. And I think you lose the scale of this rocket when you see it on the screen. And we've been out there and had the opportunity to look at it. And if you get a chance to come here, come and look at the size of this rocket. But we have a demonstration for you of actually how large this rocket is. The amazing graphics designers of NSF have done some work to show you the scale of this rocket. It is 141 meters tall, and there are some very familiar buildings coming up. The Statue of Liberty, Big Ben, and the VAB, the Vertical Assembly Building at NASA in Florida, is 160 meters approximately. So this is a big rocket, 123 meters from the bottom of the rocket to the top of the rocket, and now we're going to put it up against some other well-known rockets. EJ, look at the Falcon 9 over there on the left, and the big boy, the SLS. We just launched the first New Glenn a couple of weeks ago.
Yep.
There's the Great Space Shuttle at approximately 56 meters.
My favorite.
So you get a scale of these rockets up against the LVM-3, the Vulcan rocket, and again the SLS, again carrying humans into space. This is the largest rocket ever flown. And here in about 51 minutes, we are going to hopefully see this one launch as well. So the Block 2s, this is the Block 2. This is the Block 1. You can see the difference on your screen there. They've changed the configuration inside the ship as well. We're still flying a Block 1 booster, but we have a Block 2 ship, so it's a little taller. It holds a little bit more fuel. And if we really wanted to go down the rabbit hole of that, we could get Alex in here to talk about it. But I think I'm just going to give him a break for a minute, because what they did is they did shrink, I think, the payload volume just slightly to give it a little bit more fuel.
Yep.
But as we go into the Block 3s, we're going to see that stretch. And hopefully Alex is nodding that I'm saying things right and not shaking his head when I'm saying things wrong. Thank you. I need that confirmation. So, EJ, I mean, this is a massive ship that they're about to.
It's a monster.
It's big, and it's only going to get bigger.
Yep. I'm very on board. This thing is an absolute unit of a rocket. Remember, we're flying with twice the thrust on this thing as the Saturn V. And the Saturn V is the one that put people to the moon, which is pretty crazy. And hopefully, you know, with the help of Starship, we get back to the moon someday. But I'm telling you, this thing is a monster. That first stage is 22 stories tall, right? So picture a 22-story building. That's what the first stage is. And the second stage isn't no slouch either. Mm-hmm. It's, I don't know, probably like an 18-story building at this point, but it's going to get to the point where it's 20 stories as well when they stretch the thing, like what you were saying. These are not small vehicles. This is it's truly a new era of commercial spaceflight here with vehicles like this. We've never had anything like this. Like the guys during the Apollo program, they wish they had something like this, you know?
And the goal is to get 100 tons to low Earth orbit, and then eventually to take us back to the moon through the human landing system, which is a modified variant. We talked about that earlier, the modified variant of the Starship, and then also eventually humans on Mars, making us a multiplanetary species. Now, I'm looking down at the monitor. You guys are seeing the same thing I'm seeing. Is that sunshine above the rocket?
Yeah.
Or am I just seeing things? Adrian?
It is continuing to clear up. Everything is starting to look good. I'm also, I'm no Ryan Caton. Ryan Caton is, I think, with you in the room here. But I'm also having some maps here. And we can also see the Gulf clearing up. We can, in terms of planes, we can see clouds being less and less prominent. It's right now what we want to see, honestly. Everything is moving more in the right direction. Nothing is moving in the more wrong direction. There, that's my screen presenter. You can almost see, like, of course, that's also not a flight corridor. I will also mention that. But you can see there's just a few final planes in the path of Starship, and they probably, hopefully, are in communication with the towers to make sure they're out of there before this thing flies. But everything is looking more and more promising.
That looks awesome. Thank you for that. And, you know, we have folks all over the place here at Starbase. Not only were they setting up cameras, we here at the hotel at Margaritaville Beach Resort have Doss up on the roof, and we may check in with him in a little bit. But we also have the one and only Jack Beyer, who's at Rocket Ranch. Jack, what's going on out there at the outpost? We had Jack.
Well, he's
Jack's
got a lot to say, clearly.
Jack's having too much fun. We can hear you now,
wait a minute.
Jack.
There he is.
Testing 1 2. Hopefully you can hear me all right, and I'm not a robot. Things are going great at the ranch. There's a bunch of people here. The atmosphere is lively. The NSF feed is on, so we've been listening in to you guys joke around, which is why I've been annoying you in the back channel. But yeah, I've got the old Triclops set up. It's a 500 millimeter lens on a Canon R, a 2400 millimeter lens, effective focal view, on a Canon R5 Mark II and an iPhone at at 5x. So Triclops, that's the camera rig I'm going to be running for this. I do have the drone as well. We'll see if the winds cooperate enough for me to get that thing in the air. But yeah, very excited for the launch. I know the weather is less than ideal, but I see the sun right now, which is something that couldn't be said for the rest of the day. I see the sun. I see like some actual rays of light. So 5:45, let's get some golden hour launch action. This could be a really beautiful one.
Yeah, I agree. And what you're seeing on your screen right now, folks, is Jack's camera. You can see the OLM continuing to vent there. But what you can't see are the groups of people that are around him at Rocket Ranch, out at the outpost, and you can join them. Go check out Rocket Ranch's website, and you can be one of those that sits next to that camera and talks to Jack's ear off and asks him all kinds of fun NSF questions about cameras and rockets and so on.
I don't think that you can get any closer to the Rocket
joke,
Ranch,
Gene.
right?
You joke, Gene, but I do enjoy every time people come up to me and say, "Hey, it really means the world when people come up and have kind words to say or mean words. You can say whatever you want. You can be like, "Hey, you suck," and I'll be like, "Oh, yeah, you're probably right." But seriously, Rocket Ranch is awesome for hosting us for all of these launches, for hosting one of our cameras, and like you said, it cannot be said enough. It's just an awesome place to watch the launch from here. There's
absolutely.
Sir,
yeah, we got Robo Jack. So somebody go reboot the Jack. He's out at Rocket Ranch with the outpost, surrounded by a bunch of other rocket folks. So one of the things they have out there, we encourage you to bring your families out to these events. This is the future. What you're seeing right now on screen is one of our other great photographers. This is from D. Wise's camera, and again, you see some of that fog, but you heard Jack you heard Jack clear, it's clearing up a little bit. Another one of the remote cameras that we have here at NSF, we're going to go through these so you can see what these cameras see in real time. And as we go through, you're going to see from farther away, right? You're going to see closer up. And it's all because of you guys helping us do what we do. We don't control the weather. So I wish we did. I wish we could just, say, hey, nice. We need some clear weather for this launch. But, we can't control where these cameras go. Looking down the beach here from Margaritaville across the inlet, this is Doss's camera up on the roof where we are at the studio. And what you see is people starting to gather, people starting to come up and look. And there's a wider shot from the top of the Margaritaville Beach Resort here on South Padre Island.
Yeah, that's our current view. Somewhere out there in the fog is that, what you see on the screen right there, somewhere out there. But we can't really see much from here, Gene.
Now, is this affectionately Danger Dune, right? This is the one we put right out there. Is that right?
Yep, that's Danger Dune.
Yeah. And you were out there the other day. You were helping put the cameras out. I was for Flight 7. You're tromping around the dunes. Talk through a little bit about some of these cameras as they went through some of the remotes, what it's like being out there and being on the property, setting up the trailer and all of that.
Well, I tell you, the first and foremost, the craziest thing is being recognized out there. Jack was just saying that, like, oh, people are going to come up to you, hey, you're awesome, or you're going to be like, hey, you suck, like what he said. No, we don't get the latter there, but there's a lot of people that do come up and recognize you. It's really cool, but getting out into the dunes and being out in the thick of it, it's mostly just take this equipment here and move it over there. Take that equipment here. And I was like, hey, BJ, move this here, move this here. I'm like, okay, all right. You're moving batteries out there. You're moving cameras out there. You're moving connectivity equipment out there. You're moving everything you can out there, and you're trudging it through these dunes. Mm-hmm. And then you just see what you see on the screen right there.
Yep.
That makes it all worth it. You get to the top of this dune, you feel like Rocky. You're like, yeah, Adrian, right? You get to the top, and then you see the rocket there, and that's the payout, right? And then you lug the battery down. You're like, wow, I'm not as young as I used to be. Oh, geez. But yeah, it's fun being out in the dunes because you get to see that Starship up close. And keep in mind, there are cordoned off areas around Starbase that you really can't go. And read the sign, don't go where you shouldn't, but you can get pretty dang close to this thing. It's unprecedented. There's been nothing like this. Like, no one could just walk up next to a Saturn V. But you can walk up next to this as long as you stay within those signs. You don't want to make the sheriff upset.
I was about to say, stay outside the boundaries. You can get very close. You can't get right up next to it. Be respectful of SpaceX property. Stay off their property. They allow us to get this close for now. for now. We don't want to mess that up for anybody in the future. These are some of the great remote cameras. And then we go back to the
I think I
danger,
have
which
to
is
quickly
super-
cut in here.
Go ahead, Adrian.
We have loading of the ship.
We're starting to see some propellant load, and are we seeing frost lines
Yeah,
yet?
the tower vent is off, which means we are in the situation where we will have propellant flowing into the upper stage of today's flight, and we also are very close to the tower vent dying off if this schedule holds to have all 4 tanks loading here very, very soon. So yes,
in fact, you can see some of that frost already on the methane tank. About to see it also on the liquid oxygen tank because it's a bit discolored as well. That's sort of the process well before that. We can also see some venting from the engine chill vents. It's not engine chill time yet, but they start venting when they start this propellant load. And then once that chill down is actually underway, you see a lot more venting. It's sort of like a trickle right now compared to how they'll be later down the countdown. You will start seeing soon as well some frost on the booster methane tank because they've already started that as well. And later, bit like 5 to 10 minutes from now, we're gonna see the same for the liquid oxygen side of things. We're gonna see also that oil and vent disappear.
And once that frost enters the vehicles, the propellant enters the vehicles, you'll see the frost line slowly start to climb up. And that's condensation on the outside. These are cryo propellants. These are very cold propellants they're putting in these vehicles. And as that frost line comes up, that'll tell us where they are in the loading process. And we know we're just about 40 minutes from the T0. Now, Alex, do they have a hold point at any time in the countdown?
Yeah, they indeed have an option to be able to hold at the T-minus 40-second mark. So we still have a long ways to go if they want to take some time or anything. They usually run the propellant load sequence first, and then at the end of that, at T-minus 40 seconds, they pause there if they need to. We are hopeful, though, that they don't need that time, that they are all ready to go, and that everything is looking great. But if they were to need some time, they have that option at the T-minus 40-second mark.
Well, we're going to pause here, and I'm going to send it back to Adrian because I'm watching the chat, and I see all of this amazing support come through, and we want to be able to thank those folks that are being generous and helping us provide this amazing launch coverage.
Absolutely, there's so much support. We have Void gifting 20 Reti memberships. Thank you so much. And then we have Kirby gifting 80 Reti memberships. Over 4 different 20 Reti memberships. Thank you so much for all of that support. That's so many people that can now watch, for example, the normal behind the scenes like multi-view. They also can watch the production behind the scenes where you can hear Kevin and Jay and the production team working in a few minutes and like getting calling the launch, which is honestly quite amazing. Like I always watch that myself. Once we are done here, like I always watch how that sounded. Super cool. We have a $100 super chat by Roseanne, which says really not need to start a launch seed fund for Jack. Thank you for that. We have, and I also want to mention something else here. We have so many store messages. I have zero chance reading them all. But I will warn you all, this patch 8, is flying so fast off the shelf right now, and I can't blame you. Honestly, Jack did an amazing work with it. It has so many cool details. I mean, it has the planetary alignment on it, if you want to look at that. So, it's amazing, and it's flying off the shelves, and I want to merely make sure that if you want it, it's flying off quick. And so that's my quick support setup.
Thank you, Adrian. And thank you guys so much for all that support. We have confirmation that they are loading locks into the booster, and we're gonna bring up a graphic so you can see what it looks like inside the ship. EJ, talk us through this propellant as we look at this graphic for the booster and the ship.
So Starship is a bipropellant, bipropellant fully cryogenic rocket. So you have liquid oxygen and you have liquid methane. Both of those are very, 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 very cold. But as we were discussing a little bit earlier, you want to get these in there as quickly as you possibly can. And remember, the booster and the ship, because they're 2 stages, each one of them has a liquid methane tank and a liquid oxygen tank. Now, the key here, if SpaceX wants to load this the quickest they possibly can, is to get all these tanks filled up at the exact same time. Because remember, these fully cryogenic propellants are boiling. They are boiling, and they will eventually boil off. Like if you had a pot of hot water on the stove, right? If you left it there, eventually there will be no water, right? Yeah. It'll just all evaporate. These propellants will do the same thing. So you got to load them as quick as possible to maximize performance of this already monstrous vehicle.
Mm-hmm.
So basically what they're doing here is with going into the final booster LOX load here, they're going to make sure everything's topped up at the same time. And that basically is just a good sign that we're gonna see something here. We're gonna see some fireworks here, hopefully.
And when we see those fireworks, we're actually going to see some detonation protection systems.
Yep.
Alex, why don't you jump in here and talk us through the deluge system and some of the other safety mechanisms they have at the launch pad?
Yeah, they have that deluge system. Instead of having the traditional tower, right, to push out the water, they have the nitrogen system. The water is pushed out to the plate. The water sprays out sort of like an upside down shower head of sorts, right? And that's essentially what does it. That's one of the protections that they have, of course. In the future, this will change. They're going to have a proper flame trench with a flame diverter and everything, as we see on traditional launch pads, but that's going to be at Pad B. For the meantime, this is what they have at Pad A. It works for now, right? And so they obviously will optimize that with the Pad B launch hardware, I guess.
And when they do go to that Pad B, we're going to see that 2-directional flame trench, and that's going to be water cooled. Are we going to see, like we normally do on these flights from the Pad A, are we going to see that big spray of water, or is that going to all be down in the flame trench, Alex?
Most of it will probably be in the flame trench. One of the big question marks is going to be how they're going to be cooling down the OLM, because the launch mount will be water cooled, right? But so is the flame deflector on Pad A, and it still shoots out water out. We don't know if it's going to have any sort of similar mechanism where you have holes to let that water out at high pressure. It might not. We'll find out once we see that hardware a little bit more up close, and we also see it in operation. But that's a few more months down the line.
And there on your screen, you can see on the left the new tower they're building. And that's going to now, it's on the right-hand side because we switched to the Danger Doom view. You can see the tanks, that frost line kind of building up there as the fuel goes into both the vehicle and the booster. At the booster at this point, the next step is going to be where they start to chill some engines. And I mean, we're listening in. When we get information, we're going to take it to you. We've got more folks in the field that I can talk about, but I know we have Jack, who's out at Outpost. We talked to Jack earlier. We've got some shots from D's camera. D Wise is there. They've set up their cameras all over. Also, Max Evans, talked to him today on the stakeout earlier today with Max's cameras everywhere. And I think so this is Jack's camera here that we're looking at from Outpost. Look at all that. It looks like fog going across the ground. That's actually the venting from the tank farm that you see while they're doing the propellant load. It's a pretty cool shot. And the Outpost and Rocket Ranch is such a great location because, as we said earlier, that's as close to that as to the launch site as you can get, because that's where that roadblock happens. Again, it's a great shot of the tanks. You can see them with the frost line coming up. And Alex, I have asked you this like 5 times, and I keep forgetting. It takes about how long? Like, what's the fastest they've loaded the vehicle? Is it 40-something minutes? The whole sequence starts at T-minus 46 minutes. They're going to go down, hopefully in the future, to 30 minutes or even less than that. Their plan is to launch this, fuel it in less than 30 minutes. And this is part of that rapid reuse that they're trying to do here at SpaceX. And again, I reiterate, everything you see on the screen is research and development. The purpose of this flight today not only is to make us go, wow, it is to get data, right, EJ, coming back from this launch. We're going to get data on the launch and the healthy U-33 engines, hopefully, the stage separation, the flip and burn maneuver, and then all the other things that they plan on doing while in orbit. Currently, I guess did the sun go away? I was there for about 2 seconds, but we're able to see really good shots from. That's my favorite shot. That's the one I like right there from
Danger Dune, man.
That's what. Yeah, because talk about Flight 7. When we saw on this camera after the fact, we saw the launch, and then we saw as it pivoted up, because this can rotate up as it launches. Talk us through Danger Dune real quick.
Well, we actually have a couple of different cameras out there. There's one that points basically at the rocket, and then there's another one that was from an NSF contributor, Jay DeShetler. And that camera actually has one facing towards the pad and one facing up at 45 degrees. We got that booster coming in from that camera.
There it goes right there. It's actually showing you live on screen what we're talking about.
That camera is actually fixed. And now that gets me to the next one, which is the Danger Dune camera here, which is right next to it. And that one is actually a PTZ, a pan-tilt zoom. It can move around, and we can actually watch this thing come in. For Flight 7, we got views of Super Heavy coming in, looking up the rocket engines. That was awesome. That's one of my favorite shots there from the entire cast. This camera can pivot all the way up, and you can see that Super Heavy booster come in and just maneuver over into the pad and make it look easy. And that it's just a wild shot to see that right there.
Yeah, and look how fast that panned down. That's what it's going to do. It's just going to follow that rocket as it comes in. Now, at launch, it's going to get covered. It just gets covered with the exhaust and the vapor coming off of that. Now, the water deluge system that Alex was talking about earlier, it suppresses not only the sound, some of it, but because you hear it, and it suppresses some of the shock waves as well.
Yep.
Right, but it still blows a ton of debris. Does it actually turn that into steam?
Yeah, so the shower head there is basically part of what's called a pad deluge system. And that pad deluge system is using water to dissipate sound. It's using water to dissipate heat. It's using water to dissipate pressure. I mean, pressure and heat are kind of hand in hand here because we're talking about gases, right? But basically, it's there to dissipate any energy that the rocket's going to have. Like, obviously, you want it to dissipate energy because you don't want to melt what's below the rocket. We've seen the results of that.
Yeah.
What happens when you have nothing down there? The heat will find, and pressure will find something to break, and it will break it and shoot it into our van. That was fun.
That's right.
Yeah. So you want the water down there to basically dissipate dissipate the pressure down there and dissipate the heat. It will turn to steam, absolutely. And it's also there to absorb the sound. Water's also good at absorbing the sound because the rocket, and this is not just Super Heavy, this is pretty much any rocket. Rocket engines are so ridiculously loud that when you're leaving the pad, the sound reverbing off of the deck of the pad and off of the ground is enough to induce vibrations on the vehicles. Not quite the same, but very similar to what we saw on Flight 7 with Ship 33. It's enough to induce harmonic resonance on the vehicle and cause something to break. Right? A good example of that would be on STS-1. The SRBs were a little too spicy. They put a little too much jalapeno in the propellant. They don't do that. But, hey, you understood what I was saying, right? They put a little too much spice, and the SRBs actually overperformed. They overperformed so much that the sound from the SRBs reverbed off the ground and shook tiles off of Columbia. Now, thankfully, Columbia did come home that mission, but the sound from these vehicles is so ridiculously powerful. It can actually damage the vehicle on the way up. But that's why they throw all that water down there. That's why on Pad A we have that shower head. That's why on Pad B they have those flame buckets. They have those diverters to get the flames and the heat and the pressure away from the vehicle and the sound as well.
As we get closer to this T0, we are under 30 minutes, and I want to see some stuff in chat. I want you guys to go crazy as we are within 30 minutes. We're now T-minus 28 minutes, 20 seconds from launch, and that's a big deal. We should start to see things in rapid succession as we get closer. You can look on your screen. You can see the frost building up. Once this vehicle is fully fueled, I'm going to bring Alex in here. We talk about they have a potential 40-second hold, but you can see the clouds above the launch site. From our perspective, there's still some ground fog. We can't see anything, but we have these cameras, and they are going to bring you some amazing views. But Alex, some of the things that are going to happen in this timeline as we go forward. The next big thing we're looking for is for some Raptor engine chill. When is that going to start?
Should be in about 8 minutes or so at T-minus 19 minutes and 40 seconds. That's sort of the plan for the Raptor chill down.
And is that both the booster and the ship?
Yep, both stages at the same time. All 39 engines getting chilled down.
It's almost like a progress bar on your screen. When you see the frost, you can see the frost going up. It's a progress bar, and we all want to fast forward and get to that point. Adrian, I want to bring you into the conversation. You've seen as many Starship launches as the rest of us. We need that progress bar to go faster. How do we do that? How do we get that progress bar to go faster and fill the ship? I think it has to do with all the great people in our chat.
Oh,
See what I did there? There's a shovel pass, as they say in football.
I totally was about to answer the question how to fill up Starship quicker.
Tell us. We all want to know. We want to know. Give that information to SpaceX.
I mean, honestly, they're doing that every single launch. Every single launch, they're installing more pumps, they're installing more subcoolers, more vaporizers, and they're fueling this up faster. And to be fair, there's a pretty big rumored booster quick disconnect redesign coming up, and if they really go with something like 2 connectors or stuff like that, we could be up for like even faster refill on the next version of Starship.
Oh yeah, so, one for the LOX and one for the methane. Oh yeah.
Bigger pipe means more going through pipe.
I think we were joking about that the other day. If SpaceX would name it LOX Inlet 1 and then Methane Inlet Bravo or something crazy. They would name it something crazy.
Stop it. Stop it.
I'm getting some heat in the back channel from the one and only Chris B. I should have said American football because, football, shovel pass, whatever. Yeah. Adrian, let's thank some people.
Wait a minute, because there's shovel passes in the rest of the world football?
There isn't.
Come on.
No.
We have Bob Long here with a $20 super chat. No message attached. Like, just a warm thank you back. Thank you so much. Also, the panelists getting a bit iffy here with all these store orders. I'm just saying. Apocalypse Cow, we have a 20 Red Team membership here. Thank you so much for that support, Apocalypse Cow. I think that's the 3rd or 4th time that we have heard your name now on this single stream alone. So, thank you so much for that. We have DDA 40X fan upgrading to launch director. Thank you so much for that generous support. We have Nancy Taylor becoming a flight engineer.
Wow, thank you.
Yeah, these are the highest level of support we have, launch director and flight engineer. So this is incredibly generous. Thank you so much. We also have so many people pointing out the amazingness of that patch. So many messages coming in about that. And we also have Kirby here coming in with, after the memberships that were already gifted by Kirby, now coming in here with just a super chat saying the commentators are awesome.
Well, thank you very much. Yeah, thank you. We do this because we're rocket nerds, right, EJ?
Oh yeah, thank you very much.
We just love this like you guys love this. We want to see rockets fly, and that's why NSF, as the crew that we have the cameras that we have, and we have the people all over the world that commentate. I mean, it's not just one company. There's so many great companies out there that are pushing human spaceflight to the envelope and taking us to places. I mean, we just saw the lunar lander was at the second commercial lander ever on the moon, and I think the first one flipped over.
Yeah, the first one was Intuitive Machines. The one that we saw land the other day was Firefly.
Yep.
Firefly Aerospace with the Ghost Riders in the sky.
Fantastic.
Blue Ghost 1. And man, did we get some good pictures from that.
Oh,
it was great.
Stunning. And you can see those pictures if you follow us on all our social medias. You can see them on our Facebook page, Instagram. We share them on X. And we have some great writers that are actually bringing you space news. And for those of you just joining us, let me tell you who we are. We're NSF. We are NASASpaceflight.com. We're a bunch of rocket enthusiasts, rocket nerds, writers, camera people, personalities. Go ahead, Alex,
guys, I have an update. We have a hold in the count, apparently. The flight director just went into the countdown sequence and he said there's a hold. The usual hold.
So talk us through what that means.
Go ahead.
Yeah, Alex, if you want to talk us through, Adrian, talk us through what that means.
It looks like they're still troubleshooting something that they may need to target another new T0. It's still too early to tell. They have that hold at T-minus 40 seconds, so they may take that with this hold and be able to troubleshoot all of that. The clock is still going as they have that optional hold, but they have called the treble hold call out, of course. So that probably means they're gonna go to the T-minus 40-second mark and then being able to hold there the countdown and be able to shift that T0 into the window. We don't know how long it'll be. They're still looking at that issue.
Now the T0
He went a little bit too fast, by the way, so I'm catching up on what exactly he said.
Well, we appreciate that. There's a great shot of the top of the ship there. You can really see those flaps we talked about earlier. So the clock is continuing to run at minus 21 minutes 30 seconds. What you see on your screen now is the SpaceX feed. We'll kind of pop in and out from there as we get information. We'll show you what we get as we get it. And as Alex said, they can go all the way down to 40 seconds and then hold there. They've already pushed the launch. Alex, Adrian, I'm going to bring you guys back into this conversation. They've already pushed the launch 15 minutes into the window. So they have time to troubleshoot going forward, right?
Yeah, it's a bit different than what you're used to on Falcon 9 launches. Falcon 9 launches are really like down to the second from the moment auto sequence starts. So they are kind of locked in there. Starship has way more wiggle room. Starship is still able to top off. Starship has, as we talked about, the T-minus 40-second hold. However, hearing a triple hold call is certainly of note and significant. Like, usually that is something that is being called for, something that is being troubleshooted. So, like, a triple hold call in the countdown is at least interesting, because that's not somebody chiming in being like, hey, we are still looking at something. That is the LD really calling out the situation. So that is at least interesting.
And what they're doing in the control room now is they are going through the health of all of the systems. They're looking at the GSC, the ground support equipment. They're looking at the health of the rocket. They're looking at the health of the engines. EJ, jump in here, because in the control room, they want to make sure, and again, I can't say this enough, but everything you see is a test flight. This is a test, right? And so when they find something that's an anomaly and they call a hold, they want to zero in on it. It could be a problem. It could just be something that's slightly out of tolerance, and they'll make those calls as they go through and look at all this data in the control room, right?
Yeah, that's basically what they're going to do. And it's important to note that the count didn't actually stop there. The count kept going. So whatever problem they did have, whatever problem they're reviewing or troubleshooting is obviously not that big of a deal. They would have stopped the clock if they saw something that was super serious. But yeah, in the event of a hold, you're basically going to figure out what's the next steps. If you get a hold in the count, and I hate saying this because I don't want to jinx it, right? But when you get a hold like that, basically what happens is you put the rocket back into a safe state. You basically get it right back to where it was before you started your count, and then you try to figure out what went wrong from there. Now, every rocket has its quirks, you know what I mean?
Yeah.
But basically, the flight controllers will be reviewing, going through, identifying what went wrong, why it went wrong.
If something went wrong.
We don't even know that. Could be a bad sensor. Yeah. Right? Could be, if you get you got to verify, though, that it's a bad sensor. You have to be absolutely sure. And then you make a decision based off of what you find if you're sure. But once again, we didn't really see a hold there. The count kept going. They did call a hold. So there was something that they saw, but the clock didn't stop. So even, SpaceX clock didn't stop. So I guess we're still going to go. The next gate that they would have is T-minus 40 seconds. Yeah. So we'll see what happens when that happens. We got some time here.
Yeah, and that's what Alex was talking about. So as the countdown continues, we're T-minus 18 minutes and 18 minutes. We're going to look at the trajectory of this flight. I'm just watching the clock. It's 3 seconds. I should just say T-minus 18 minutes. This is going to launch out to the east. It is going to, and there on your screen, you can see the trajectory. It's going to fly in between those islands. It's going, and this is well after the stage separation. It's going to cover the southern tip of Africa, and then it will begin its re-entry trajectory, aiming for the Indian Ocean, a soft splashdown in the Indian Ocean. If you've joined us for other launches in the past, some of the camera angles coming in from the ship when it does the flip and burn maneuver is pretty amazing. A couple of them we've seen at night, a couple of them we've seen during the day. But this is not I'm going to say that slowly. This is not an orbital flight. This is a suborbital test flight. The ship, after stage separation, will get to its trajectory. It will go through its test sequence. During the flight, they're going to perform several tests, scientific tests on the ship. Hopefully, knock on wood, we get past any holds going to countdown. And what we'll see is satellite deployment potentially. We'll also see a on-orbit, an in-space relight to demonstrate relight. And what you're seeing now is in the lower right-hand corner is the Indian Ocean. And apparently those are some buoys. That is a buoy cam in the Indian Ocean. That feed is coming from SpaceX.
No, that's a replay of how it looks like when the Starship the Starlink deployment should happen. This is from Flight 6. This is from Ship 31, essentially, and it's sort of a view of how it will look like when they deploy those Starlinks. So it's not going to be the best of views. It's around that 17, 18 minute mark, right? This is not. Yeah, thank you, Kevin, for the replay mark. This is a sort of an idea of how it'll look like once they are into that part of the flight. Very dark.
That's a cool shot. I like the Earth with the sunlight coming up. That's kind of nice. But yeah, okay. Thank you, Alex, for that. I read the wrong thing. That is a replay, and hopefully we'll see that today. We will see that if Starship launches in 15 minutes and 42 seconds. And separates. But remember, as they say at T0 at SpaceX, excitement is guaranteed. So we'll see what happens. In the other shots there on the screen, you can see Starship 34 on top of Booster 15 is continuing to load. Well, I say that. Am I correct? The progress bar of frost is moving up the tank, right, EJ?
Yeah, it seems to be trending upward. Alex, what do you think?
Alex.
Not Alex, Adrian, but yes,
okay,
they're still
Adrian,
loading.
what do you think?
I'm jumping in. Yes, they're still loading. It's an interesting situation. I'm not aware of other rockets calling a triple hold and then just continue to load. Quite interesting scenario we are in here right now. But yeah, they seem to be continue to hold. I'm also looking at the NOAA satellites updates from the clouds and everything, and you know what you can also see at this point? The shadow of the sun going away, rapidly approaching Starbase, because this thing at this point will launch in twilight-ish conditions.
Yeah, and that's going to be amazing. When and if it launches. Now, the current T0 is set at 14 minutes and 14 seconds. So, they're going to finish out, and we're looking out for some of those calls from SpaceX, like prop load complete. We're looking for other things. I know Alex is working a million things at one time. We are looking at a live view of the ship on the OLM, on the launch mount, and ready to go here in just under 14 minutes. But again, we had a hold call. We don't know why. We don't know what's going on. We don't know if it's wrong. We don't know anything, but it looks like they are going to continue propellant load, and the countdown is going to continue, and they may or may not hold at the T minus 40 seconds. Now, Adrian, how long can they hold at T minus 40 seconds?
I think the last update we got was up to 30 minutes-ish. It's of course always depending on potential tank farm and also flow optimizations. We don't have a update on current version, but the last updates was about 30 minutes-ish. And the window right now with the current T0 would go for another 45 minutes. So that is the situation right now.
Sorry, did I hear you correctly? The window is 45 minutes, but the hold can be the entire 45 minutes?
No, the hold can be probably, at least from our latest update, was about 30-ish.
Okay.
Of course, it's an experimental rocket, right? Could they have expanded that hold capability? Yes, totally. Is there maybe a wiggle room? I don't know.
Yeah.
That's actually outside of our knowledge base, but somewhere between 30 to the minimum and 45 to the maximum is their hold.
So we were expecting a engine chill call about 8 minutes ago. Did we get that call out from SpaceX? Did we hear that? Alex or Adrian, did we have that?
Sorry, can you repeat that? You cut out for me.
The
for beginning
Raptor
there.
chill normally begins around the 20-minute in the countdown. Did we or did we not hear that call out from SpaceX?
I'm not fully sure if we heard that.
Okay. So at T-minus 11 minutes, or just under 12 minutes now, we should have heard the Raptor engine chill call out. But I mean, again, we are in the window. Okay, the T-minus the T0 right now is at 5:45 Central Time here in Starbase, Texas, and on your screen is the shot from Doss, who's on the top of Margaritaville Beach Resort. So it does look like, as the sun is setting, we are getting some clearing. At least we'll see a little bit of the rocket. Please get better. Please get better, because the view from the Margaritaville is amazing. And again, as I was saying, that T0 time in the upper left-hand corner is more than likely, and guys, cut me off if you think I'm wrong here, and yeah, that's definitely filling both the ship and the booster still. It's going to get down to T40, and it should stop. We are expecting it to hold at T40, yes? EJ, what do you think?
It's possible. It depends on how bad the hold was, Adrian, right?
Yeah.
Am I thinking about that? It depends on what they were trying to fix. It seems like they're keeping going with the count while they're troubleshooting problems, right?
Yeah, they said, or the current plan is they will hold at that point if they don't clear the issue until then.
Okay, so but we don't know whether they've cleared it or not. So the real marker here is,
let's see.
Yeah, so the real marker here is if it gets to T40 and doesn't stop. That's really what we're looking for at this point, as we are coming up on T-minus 10 minutes from potentially the launch of Starship Flight 8. We are hearing things in the background. Some things are going on. It might be up on the roof. It might be somewhere else. But this is what it means to do live television as we cross the T-minus 10 minute mark. And as I said earlier, we are a go at this point until we hit that T40. If they have cleared the hold that they called earlier, then we are going to go right past that 40-second mark. If they haven't, they're going to hold there, and then we'll all be sitting with you waiting for this rocket to launch. We should get the propellant load call here in just a few minutes. We're gonna wait for that call out, and we should have already had the Raptor engine chill call according to the timelines we've had in the past. Now, Adrian, these timelines change. They change with each flight.
Yeah.
So
yeah, and I have to chime in here. Apparently, they think they are clear with the issue.
Oh, nice. Nice.
So apparently,
Look at the flaps. Look at the flap.
Yeah, look at the flaps moving.
Oh.
Look at that.
Yeah, going into, I'm going to call it flight profile. I like that. They're doing their flap checks.
There we go. She's flapping.
And that's a great graphic on the left-hand side. You see that at the very top, that open space, that's actually the payload area of the ship. And then you have the propellant tank. You have a large tube that goes down the middle that flows propellant down to the engines. And then on the outside of that tube, you could see that's the other propellant in the lower tank. And the same thing on the booster. You have an upper tank and a lower tank, and then a transfer tube that goes right down the middle of the ship. In fact, the booster, the ship has 4 of those, right, Alex? Right, EJ?
Talking while muted. Coming in.
Yeah, go ahead, Alex. We were talking about the transfer tubes and how the new Block 2 ships have 4 of those, 1 central and 3 for the vacuum Raptors.
It used to be that there was only a single transfer tube from the methane tank down to the engines, and then there was like a manifold at the bottom of the liquid oxygen tank. Now instead, they still have that central transfer tube, but it only spreads and it flows out to the center 3 engines. Now each individual vacuum engine has its own transfer tube, so there's 4 of them inside of that liquid oxygen tank. They need those transfer tubes because the methane tank is on top of the liquid oxygen tank, so they need a way of being able to transfer that methane from the methane tank down to the engines. So that's why they're called transfer tubes. I don't like downcomer because sometimes that fluid is also going up when they load the vehicle, right? And so I like to call it transfer tube because it transfers either down or up, right? And so that's why I call it that way. But yeah.
And sometimes we actually get camera views from inside the tanks, don't we? Remember how we used to get those?
Yeah, those were
We
more
used to get
likely in
those.
the early days of
Those are
Falcon.
cool, though. I like
They are
seeing them
cool.
slosh around.
We used to get those, but yeah, they stopped doing that for whatever reason. I don't know.
That's okay. Now we get flap cams, we get engine cams, we get payload bay cams. And one of the things that are inside the payload bay are 4 Starlink V3 mass simulators. Adrian, I'm going to come to you for this question. Why do you think they went from 10 on Flight 7 down to 4 on Flight 8? What is your opinion on that?
That's actually a good question. I've thought about it as well. So it's either some sort of load balance, which I don't think so, because honestly, the weight of these shouldn't that be that important to Starship, or it is just that they maybe only had 14, and after the first 10, they only had 4 left, and they decided that's enough for the test. Like, it could always be that they just didn't have any more and didn't bother to produce anymore, because why would they? Right?
Yeah. Adrian, Alex, what do you think? Do you concur with Adrian about why they went from 10 to 4? Did they make 14 of them and then just go, guys, we're going to do 10 on this one, and if, we don't need the other 4?
I think it's just, the bare minimum that they need to test all of these systems. But yeah.
Yeah, this is really a test for the deployment system, not anything related to the Starlink V3s anyway. They want to get faster at loading them because they've got a way to do that, a big box that loads them. And inside, for those of you that don't know, it's kind of like when we were kids, we had Pez, right? You flip the Darth Vader head open and the little candy pops out. It's very similar to that. And if we get a close-up shot of the ship, you'll actually see, it's kind of hard with this angle because the heat shield is pointing away from the tower. Pointed toward the tower is actually that deployment, that payload bay door that they have, that they're going to be shooting things out like a Pez dispenser, is what we call it. Go ahead.
Is that
a drone?
Is that from Jack?
It's trying to drone.
Wow. Outside of this restricted area, of course.
Yep.
This is far away from the launch pad. That's cool. You see the production site from on the left-hand side. Less than 5 minutes away.
Yeah,
Heart
less than
racing
5 minutes
already.
away. What are we hearing in the back channels about that hold when we come up to 42nd, less than 4 minutes from now?
Well, I have good news. Adrian already sort of talked about this before, though. It looks like the issue that they had to call that triple hold called on the count. They are working on it, and it's expected to go away at the time of the T-minus 40-second mark. So right now, they don't expect to take that hold point.
That is great
but still,
news.
Sort of looking at it.
That is fabulous news. Fabulous news. So we are, I can barely see that screen, 3 minutes, 58 seconds now, under 4 minutes. And Adrian, let's talk about the timeline here as we get within 5 minutes. What's going on inside the launch control? I know we're working potentially another issue, but they're expecting that to be cleared up in the next 3 minutes. What's happening with the vehicle and the loading?
Basically, they will wrap up loading on all tanks in a very short matter here. Just because you have reached the final amount that is in the tank, that doesn't mean it has the appropriate temperature and pressure. So sometimes there's something that is called pressing tanks for flight, which is basically either a final top off or also managing pressure a bit, maybe gas, like opening some vents, making sure that the pressure is just right, the temperature is just right, and basically once all of these conditions are met, then they are really calling, okay, all tanks are go.
And when all tanks are go, then they have to drain the propellant lines that lifted that up to the ship and also to the booster. Is that right?
Sorry, can you repeat the second part?
Well, once they get all the propellant in the ship, they still have all the propellant in the lines for the tower.
Yeah, they will usually start to, we will see the return of the vents, because they will start a bit of like an after purge. because usually it is a very bad health advice for the health of your pipes to leave methane in there if you ignite a giant source next to it. That can very quickly result in a burning tower.
That's true. We want to get all of that out of there as we approach 2 minutes to the T0, and it is going. The prop load on the ship is complete. You heard that call out. Prop load on the booster is also complete. So you're looking, with the sun in the background, a fully fueled Ship 34 Booster 15. And we are under 2 minutes to launch. And what happens immediately after launch is they ignite those 33 Raptor engines, EJ, and they let them go for what, 3 seconds, 5 seconds? And then basically once the thrust to weight ratio passes 1-to-1, that rocket lifts off, right?
Yeah, basically, they're going to get a little bit of a sequenced ignition. They fire the engines in an order to make sure they're not firing them all at the same time and put a crazy shock load on the thrust structure there. And then, yeah, they hold it. And then in that split second, the computers on board are going to check to make sure we got 33 engines or the amount of engines that's needed. Remember, it's launched with 32 before, right? It's going to make sure that all the engines are good health, and then they let it fly.
Yep. Now, as we pass 1 minute, we are coming down. We might have a hold at T40. Just remember, this was expected. This is their natural hold point here in about 20 seconds. We could see the clock stop. We're listening for callouts from SpaceX, but we know the vehicle is fully fueled, both the booster and the second stage, the Starship. If they do hold at 40 seconds, we're going to continue our commentary as our team behind us is listening in and listening to what's going on with SpaceX from the control room and things that they're trying to troubleshoot. Let's see what happens here at T minus 40 seconds. We did that stop?
Looks like they're going to be holding.
They're holding at 40 seconds. Yeah. So they are going to hold at T minus 40 seconds. Again, this was expected. Don't freak out. It's okay. They are still troubleshooting the issue. They felt confident before this that it was going to clear by this point. It obviously has not. That's a great shot right there.
I want to point this into perspective that this is the first time they're holding at T-minus 40 seconds since Flight 2.
Yep.
That's
Flight
cool.
2, and this is Flight 8. It's been 6 flights ago. November 2023.
You know, that talks to the reliability of the iterations in these spacecraft that they're putting in these vehicles and the testing that they're putting in behind the scenes. Now, we are 15 minutes into the window. We have another 45 minutes of window to go. The SpaceX team is working to clear any issues. They're probably doing another health check before they move forward, or they make another determination. So they're working the issue right now on the ship, and as we get information, we'll bring that to you. So
yeah, the word is that they were working on a booster issue. They cleared out, and now they have something coming up on the ship. So they're also looking at that.
Well, while we have this pause, Adrian, let's thank a lot of folks that they've been really generous with their support. We are going to be keeping you up to information, but I want to take time and acknowledge the support that those people have given us here at NSF.
I will keep it very short. Thanks to Christopher for the super chat here. Thank you so much for that. Thanks to Kirby for another support here. Scream at me, please, once you see something.
Yeah, we will. Don't worry.
There's also, I also will quickly mention something here because I'm sorry, I'm a rocket nerd. I need to talk about this. There's a very peculiar vent that we cannot talk about that Alex and I rarely get to talk about. There's one single vent on the OLM that tends to come up once they clear a T-minus 40 second hold, which is like some sort of fluid vent down that we expect. And it's like a very weird directional vent going up. And if we have like the right moment and the right camera, you can see that vent going up. And based on that, know they have cleared the hold. Sorry, I had to talk that. It's super nerdy, but it's such a neat little thing that we have spotted at some point.
Alex, I'm going to bring you into this conversation as we've got a hold here. Let's talk about that T0 timeline. We talked a little bit about the deluge system. We talked about the static way they ignite all of the engines, but there's fire suppression systems and all those things. What happens when we hit that like T5 second mark? What are those things that happen in rapid succession right before liftoff?
Yeah, they get down to the T-minus 10 second, they activate the deluge. If that were to happen today and then they hold after that, they will not be able to launch, right? That's one of the sort of no return points on the countdown, so that's why they stop here at T-minus 40 seconds, because this is the good time. After this, things get very active, and there's even no return points on the count. And so T-minus 10 seconds, they activate the flame deflector, that deluge system. T-minus 3 seconds, in very rapid succession, they light first the 13 engines in the middle ring and the 3 center engines, right? Those 13 engines on the middle of the super heavy booster. Then 15 of the 20 outer engines ignite next, about 1 second later. And then 800 milliseconds later, the remaining 5 ignite. These engines do not ignite all at full thrust. They're actually at partial thrust, because the booster right now, or the rocket entirely right now, is not held down. It's just sitting there on the pedestals on the OLM, so it's not held down. They need to throttle up those engines, and that's the T0 mark. The T0 mark is the launch commit. If for whatever reason nothing were ready to go, or some things were not looking good, then the vehicle will shut down the engines and not go. But if everything looks good, at T0, they ramp up the power of those engines and lift off. That's why liftoff, it's like 2 seconds into the count, right? Like they go to T0 and then T+1, T+2, and that's when it starts moving, because it needs a bit of time for those engines to ramp up to power and essentially, start moving the rocket. But yeah.
Thank you for
really
that, Alex.
Active and very quick. Like it's all automated. There's no way for any manual, sequencing.
Yep. And as soon as it reaches that 1-to-1 ratio, right, thrust to weight ratio, it's going. And what did you say? The Raptor has currently the thrust to weight ratio. It can lift. I don't know. I'd probably put you on the spot for that.
It's about 1.5 off the pad TWR. That's pretty fast.
It's going to go when they ramp those up. The word we're getting right now is they're still working an issue on the ship. We are at a T-minus 40 second hold, which was expected. If you're just joining us, you're watching live launch coverage from NSF, NASASpaceflight.com. Also on the Popular Science channel, live coverage of Starship Test Flight 8, or Flight 8 is what we call it. And on your screen right now is Ship 34, which is stacked on Booster 15. And both of them are fully fueled, and we are 40 seconds from launch. The SpaceX team is working through. They had an issue with the booster. They've cleared that issue, and they want to make sure everything is green and ready to go for this launch. Yes, I believe we did talk about the hold limit. I didn't get an exact number. I'm getting a question. Alex, what is that exact number? How long they can hold? At T40?
Yeah, I was actually asking in the back channel if we know if they have updated that, because at least from the previous updates, it seems like it's about 15 minutes. We're already 5 minutes into the hold sequence.
There you go.
Oh, clock's moving.
Holds released.
We are go. It looks like.
Launch. You're
Wait,
going to
there we
see
go.
Right when we said that, I went back to 41.
Hang on. You got really excited there, EJ.
Oh, come
I'm
on.
jonesing.
They're holding again.
The clock is
40.
holding at
Oh, no.
41, yeah.
It's
Yeah,
flight
so
one all
As
again.
soon as that clock starts moving, we're gonna break in. EJ is gonna punch me again. And
I even heard the vent. Remember what
Yeah,
Adrian
you
said
heard
about
it.
the vent? I heard it. 'Cause
That's like a
it
very.
also has,
It's a deep, like
like push.
hissing sound. Yeah.
Yeah.
Like. That's the fluid chill down.
that's okay. We've got a fully fueled ship. They're working the problem on the SpaceX
dear.
side. And when the countdown continues again, we will let you know, and I will get punched in the shoulder yet again, which is the stop talking gene. Yeah. What does that say? What?
Apparently these holds
my
were
parents
automatic.
texted me and said, "Don't punch Gene again."
Don't punch Gene.
Sorry,
Yeah.
sorry, I
So-
won't.
He boosted tripped some holes. So
Oh,
that,
okay.
just to explain that in non-rocket terms, there are usually some sort of red line monitors, and the booster basically went into an automatic sequence and probably tripped some of these red line checks, and with that automatically also triggers a hold.
Yeah, that's one of the things that they mentioned, which would explain why we heard the vent and why they were counting down, and then suddenly it tripped the automatic checks, right? And so it went back to that hold point.
Again, those sensors are working
Yeah.
as expected. They want the health of the vehicle to be as close to 100% as they can get before they launch the largest flying object into space for a second time. And hopefully, after stage separation, this ship will continue on its mission if we can clear this T-40 second hold. Let's talk about the flight profile after launch, since we've got some time to talk about that, because I said there's a nice vent. There's some good vent noises for you. Wow, they are all kinds of venting, aren't they, EJ?
Oh, yeah. You're hearing all kinds of good stuff here.
Yeah. So once it gets off the launch pad and we get to stage separation, what's something called...
We
there's
have
some information in the back.
we have a scrub.
Yeah.
We have a scrap for today.
Okay.
Offloading the vehicle. That was a depress vent.
Yeah. You could see at the moment these weird vent sounds came up, like Alex
Yeah.
and I in the camera were like, uh-oh.
Yep.
That sound, exactly the sound that we didn't want to hear. We have a scrub for today.
We're familiar
happens.
with these vents because it's also what we see when they have a test, right? And then they abort the test and we hear the depress vent before anything happens. And it's like, well, that doesn't sound good, right? And so we are trained already to hear that sound and be like, that doesn't sound good.
Again, these things happen. If it was easy, everybody would be launching rockets, and they want this vehicle to succeed.
know-
Have all these checks. Go ahead, Alex.
You probably saw this in the back channel, but this was a nice wet dress rehearsal.
Yeah, which we talked about. We talked about.
We talked about it.
That's right. We talked about
We
our countdown
did.
to launches.
Yeah.
We talked about our stakeouts. Is on this flight they decided not to do the wet dress rehearsal, which is exactly what you just saw. Fully loading of the vehicle right down to, I guess, T40. I guess on a wet dress they do it right to like T3, right? T3 seconds, and then they stop, and that means they are ready to go. And this vehicle did have an issue, which is fine. Those sensors worked as expected. None of us like a scrub, but as we used to say in aviation, takeoffs are optional, landings are mandatory. So this was an optional takeoff. This gave them some data. They need to come out and they need to fix this. So, Alex, I'm going to bring you in on this one. Let's talk about what happens now that we do have a scrub for today's test flight.
Yeah, so one of the things to consider, there are two things to consider. The first, or rather three. So the first thing right now is offload all of that propellant. That's why we're hearing a lot of venting, safing the vehicle essentially, right? So that people can go back to the launch pad, be able to work on the vehicles. The second thing is work on that issue, right? And by the way, you can see there a lot of people. Is that the outpost?
That's the
ranch. Okay, yeah. And so the second thing, as I was saying, is the issue. Work on that issue, whatever, looking at the data, making sure that they can fix it, right? The third thing is, and the most important is, what's the capability of that tank farm? Right now, they are able to do a recycling in 24 hours. So essentially, if those first two are good to go, then they will be able to turn around for tomorrow. And so I'm hearing Kevin,
Kevin likes drone shots.
yeah, you're anyways. He's distracting me because he's talking to my ear and he's talking about him liking all of these drone views.
Look at that drone
I do
on the
agree.
left-hand side of the screen. It's fantastic. So what are we looking at here? By the way, guys, don't go. You can find all the updates on our social media sites. Follow us on Facebook, on Instagram, on X, on Blue Sky. I keep getting that one wrong. Is it Blue
It's
Sky?
Blue Sky.
Blue Sky. I'm not familiar with that one. I'm old.
Well, the sky is blue, right?
Sky is
Like
blue.
just-
You're going to get all the updates. We will continue to bring you coverage also on NASASpaceflight.com. There will be updates everywhere from NSF. So stay with our socials, okay? Just make sure that you're following us. Go ahead, Alex.
Yeah, whatever SpaceX puts out in terms of information for the next try, we cannot assume that it's going to be tomorrow because they first need to work on the issue, right? Like, it could be such an issue that they may even need to destack. Of course, knock on wood, everything that you may do for good luck.
Don't say that out loud.
I know, but you got to think about that possibility. So, the worst case scenario is they need to destack, and so it's a multi-day scrub and things like that. The good part will be, they figure it out. It's a quick fix. They don't even need to do any of that, and they just try again tomorrow, same time, 5:30 p.m. Central to 6:30 6:30 p.m. Central, because that will be, if they try tomorrow again, that will be again the same window, 5:30 to 6:30 p.m. Central. And so, if that were to be the case, as usual, we're going to be back here.
Yep, we will, and we'll bring you all of the coverage and with all of the updates in between these, and we will be out in the field with our cameras, et cetera, et cetera. So one of the things that happens, look at that shot with the sun going down. And right now, have they started the detanking of the vehicle? I don't.
Yeah,
they
it would have happened right away.
Right away.
That's what those squeaky noises we heard were.
Save as much propellant as possible. That's what they want to do. And then we'll see a line of trucks coming down Highway 4 to refill the fuel tanks, the propellant tanks, right, EJ?
Yes, sir. That's what we're going to see. I mean, it's constant in there. We're down here for the launches, right? We see those trucks coming in every 5 minutes. But now there's going to be an army of more of them. So it happens, guys. Great shot, though.
Yeah.
Beautiful picture.
It is a beautiful picture. I would have rather seen a rocket launch, as does everybody else. But again, these things happen. I would rather have a healthy rocket off the launch pad than have something happen an anomaly in flight, right?
Scrubs, not ruds.
That's exactly right. So when this rocket does get reconditioned, if you will, detanked, we will be here to bring you all of that coverage. And also Adrian will be here. Alex will be here. And maybe a healthy Ryan Caton, who's feeling a little under the weather. That's why he's not on the stream with us today, guys.
So you're telling me there's a chance we will see a green screen after all, depending on how this goes?
Maybe. I'm rooting for green screen. I want to put Ryan to work. I mean, we're picking up the slack for him, right, guys?
Mm-hmm. I'll put him to work, because now he needs to edit a pickup on Starbase update.
Oh no!
Remember, today is Monday, right? So we're going out today on Monday, and Tuesdays on Popular Science. By the way, I think it's Tuesdays. Kevin will probably.
Adrian.
Context for that. Alex and I wrote Starbase update on. What was it? Friday evening, Saturday morning, with all kinds of implications in mind, and
like what
Max? Could happen.
I think that's Max.
I think that's Max. Why? Hello, Max.
Oh, jeez.
He's crying. He's giving you the wah-wah face.
With a reentry club shirt.
Look at how unhappy he is.
Out at Rocket Ridge. Go ahead, Adrian.
So and now this of course means there will be another adjustment to Starbase update because
Yep. And all of the other things NSF brings you. So be sure to set those reminders, because we will be here to do it all over again here pretty soon. Adrian, there's a lot of folks we want to thank that were here, the rock solid NSFers all the way through and are still here with us, right?
You mean sorry, I'm bad at. Do you have to? I'm German. You have to speak clearly to me. You mean
thank people.
Thank you. Kirby coming in again with another super chat. I think this is like the 5th, 6th. And I also have to thank a very regular of this channel, Biteford, with $100 super chat, just saying loving you all and thank you all. I mean, Biteford, once again, this has happened so many times. We thank you so much for always being here and supporting us. So thank you so much. Bob Morris coming in with super chat here. Thanks to NSF for covering the rebirth of the space age. I'd say rebirth, but like pace increasement.
Yeah, that's good. I like that.
Yeah, absolutely. And there's so many people coming in here with so I'm going to do this, and you now have the chance to get this patch before we start the second stream at some point, because that will accelerate the potential that this is selling out. So if you're still here, you obviously like this, and the patch is still available, but it's still also flying away fast. So if you want our Flight 8 patch, go to shop.nasaspaceflight.com, because I think it's amazing. Honestly, it's one of the best things we have ever done. So thank you so much for that. And I'm going through here what I also...
What you don't see, I'll give you guys a little behind the scenes while Adrian's doing that. What you don't see is Adrian has a list in front of him with all of your support on it. And there is absolutely no way in a stream, we can say thank you to everybody. So just know from the bottom of our hearts, thank you so much for your support, whether it's just clicking the thumbs up button, or if you gift a membership, or if you become one of our Capcom members, and you get all the access to our Discord and the back channel, the members area and all that. Like we have member streams and multi-views, and it's so much fun. But he can't do it all. Just like answering all your questions. There's no way we can get to all your questions. So he has a giant list in front of him, and he's going through. So we call out some folks that are obviously been on the stream before, but also very, very generous. Right, Adrian?
I mean, absolutely. This is so much. There's a 0% chance. Like, I would probably, they would already be in an attempt again when I'm done with this list.
Yeah.
That's how long it is.
There you go. There's another stream right there, Adrian. Adrian thanks people for 24 hours. We'll see you guys.
If
it's a member stream, then it's going to work
exactly
out.
Right.
It's a member stream going live right after this. 4 hours, just me reading thank yous.
Well,
Honestly,
we're going to be checking the weather. We'll be checking the health of the vehicle. We'll be checking in with all of our sources in the field, all of our amazing camera operators and photographers. And thank you guys so much. I know some folks were very, very generous today. It's on his list. It's just there's so much out there from your support. There's one right there. Go ahead.
Yeah, absolutely. I also want to thank Beth Sanders here with a $200 super chat, just saying thanks for the live coverage. Go SpaceX. Thank you so much, Beth. That's so much support, and we will 100% make sure to put it to good use.
And I would not be a very good host if I did not mention the dwindling supplies of the Flight 8 patch. Earlier in the stream, Adrian, you said there was about 40%. Now, is that 40% left, or is that 40% sold out?
That's 40% left. But at this point,
Pre-order.
we are eating. Yeah, we are right now basically starting to eat in the last third.
Yeah. So I would say go and pre-order it, and again, we'll start shipping those probably the end of the month, somewhere around there. But we do an order, and when they're gone, they're gone. So get out there and get that Flight 8 patch because it is absolutely beautiful, beautiful, beautiful. How long does it take to detank? Do we know how long it takes, EJ?
I'm not sure how long it takes. I mean, it's not a pressing issue, so I suppose they'll just trickle back the propellants as much as they can. I'm actually not too familiar with how that one works.
Yeah,
Alex, are you around? Can you say, do you like how long it takes for them to detank? I'm not sure.
It's usually about an hour or so. It takes a lot longer than filling it up because, and we actually got a question, a very good question a while ago on one of these full stack test streams and things like that, where it's like, why is it that it takes longer for them to drain the rocket than to load them? And the whole reason is how it is set up. When you load the rocket, you can essentially, you have the ground tanks getting emptied out, and so you have that pressure system being able to load and backfill with pressure those tanks. You don't have that system on this rocket. If you were to try to remove all of that propellant so quickly, you would essentially pull a vacuum on those tanks, and that's not good because then the whole rocket would just crumble and be crushed and everything. So they do it more slowly for the drain back. That drain back takes about an hour and a half actually, if depending on the test and how much they have loaded, right? But it takes a while. Essentially, it takes longer than the amount of time that it takes to load the rocket.
Are there any other great questions that we need to cover? Because we've gone through them when they were loading the propellant. We've gone through them. We're getting bright. Now, as it gets darker behind us, the lights get brighter and brighter. The interesting thing about scrubs is none of us like them, but they're a part of rocketry that gives us a chance to, go back, look at what we could have done better, look at some things with the rocket that they need to fix. When we get that information, again, we'll bring it to you. But they happen. It's part of the life, right?
Yep, that's just the way it goes. But tomorrow's going to be a better day. Hopefully we get some good views tomorrow, right? It's not totally foggy. Like, I'm looking for the blue sky. I didn't want to see it launch in the fog. I'll be honest with you guys.
Exactly. I mean, it was so funny. Like earlier today, I was on the stakeout. We were talking about the weather, before Adam Suker joined us. And for the last couple of days, it was like, well, we expect this to burn off. It's going to be 30% cloudy. It's going to be mostly sunny. And then all of a sudden, this fog bank moved in. And I was like, why did I open my mouth? I should have just said, it's going to be during the day. Because every time I say something, I'm just going to, yeah, it's my fault. It's not my fault. It's not my fault. But that's okay. That's okay. Again, scrubs happen. We don't like them, but they're part of rocketry. And what we want to see is a healthy rocket fly. And make it all the way through and do those tests. And we never actually talked about those tests, which we can now, since we know the flight's coming up in a little bit, in probably 24 hours. Alex, I'm going to come to you.
Yeah, one of the things that we are. Hang on, did you talk about what they're going to be doing next?
I want you to talk about what they're going to do.
Yeah, okay, yeah, sure. I'm juggling a lot of things right now, but pretty much that is essentially what I heard. So let's go to, again, what are their options right now? The three things that they need to do. The first one is they need to save that rocket so that people can come back and look at the hardware, look at the launch pad, the ship, the booster, everything, and see that they're all good to go for another attempt. The second thing is working that issue. Whatever happened today that caused that hold and then scrub, they need to look at it and be able to solve it. This could take either a couple of hours, minutes, seconds even, who knows, to days, right? We don't know. That's sort of that sort of uncertainty there. We've sometimes seen that it's taken days. Other times, especially with Falcon 9, because it has a lot more flights under its belt, on other flights, we've seen that it's just being, a rapid 24-hour recycle time that they've been able to do. With Starship now, that's the third thing that we need to look at. What are the capabilities of that tank farm, those launchpad systems, to be able to try again? So there's a lot of things that boil off. Mainly liquid nitrogen that is used to cool down, to chill down those propellants to below their boiling temperature. And then also the liquid oxygen and liquid methane boil off. The methane is returned most of it, but the oxygen is essentially vented. So they have a sort of limit in the amount of tries before they have to restock all of those ground propellants tanks. And so right now, with all of the upgrades that they've been doing recently, since Flight 7, they've been able to do a 24-hour turnaround and recycle. So if all of those first two things are good to go, if they have saved the vehicle, gone out to the pad, look at everything and everything looks good, then the second thing was solving that issue. If that issue is solved on time, then the third thing is they can try as soon as tomorrow, same window, 5:30, 6:30 p.m. Central. Will that happen? We're not sure. We're going to keep on an eye on whatever SpaceX says on their website, social media, X account, right? And so all of that will be the main thing that they're going to be doing right now, and the things they're going to be tracking as well. As I was saying before, the second thing, that second part of the whole process could even entail a destack if it were ever needed. Of course, we're not hoping for that. We're wanting to go with that launch right tomorrow. There's a fourth thing, I guess, that you could add to that: the weather, right? Mm-hmm. How's going to be the weather tomorrow? Is it going to be good? Is it going to be bad? Is it favorable for a launch tomorrow or not? Like, once you clear all of the three things, right, you now start to look at things like road closures, airspace closures, marine closures, and of course the weather. So all of the usual things that you look out for in a launch. So that's one of the last things, essentially. And so if tomorrow, for whatever reason, the weather is bad, but they can attempt a launch, of course they're going to take the extra time and be able to go again and do do all of the preparations for the launch on another day. But again, we're going to have to keep an eye on what SpaceX says. So for the time being, it's TBD.
Yeah, and the original launch window, let's take a step back here. It was Wednesday of last week, the 26th, through the 6th of this week, through Thursday of this week. So it was originally, we were looking at Wednesday, then they moved it to Friday for reasons unknown. Then they moved it to today, again, for reasons unknown. We are going to continue to bring you the coverage as we know it, but it could be tomorrow. It could be Thursday. Could be Wednesday. Yeah, we don't know. When we know, you'll know. And the best way for you to know is to follow us on all of our social medias: Facebook, Instagram, Blue Sky, X, the Everything app. Follow us there. Follow us on NASASpaceflight.com, and you'll get those updates.
Hey, you remembered Blue Sky that time.
I did that time. I know.
All
I'm a good boy. I know. I can be
Right
taught.
now it's turning orange though. It's orange sky.
It is on
It's
the
orange?
on the left hand side of the screen.
It's orange.
That sun's going down behind that rocket.
Apollo 13 vibes, but no 13. Excuse me, 16. Ooh, jeez. Wait, did I get it wrong again? 17.
Number.
Too many
Somebody-
things to juggle in my mind. Sorry, guys.
Reboot the Alex.
It's
He's glitching.
more than 1 a.m. here in Europe.
You know what's bad
so
when
yeah.
Alex starts to forget stuff.
Yeah,
how much
right?
is going on.
I know.
That's bad, man.
Yeah, but anyways, I saw in chat, like, are we gonna have a countdown to launch? This is now the countdown to launch, I guess. Stream.
That's right.
Every stream from now on is a countdown to launch stream until they actually launch. I guess we were having this launch stream and we were counting down to that launch, and unfortunately they scrapped. So we're still counting down. It's just that it's like TBD, right? To some, very fussy target in the future. But yeah, oof. It's already late here. I've been awake for a long time now.
It's okay. We were here. We're looking at various camera angles. Obviously, on the left is Starship. It is being detanked after a scrub. If you're just joining us a little late, they are detanking it. They're going to recycle everything, refill the tank farm, and then we will see what happens when we get to tomorrow or the following day. But it's a minimum of that. On the right-hand side, you can see a beautiful, beautiful faraway shot of the rocket. Is that us? Can you finally see the rocket? No, we can't. From the Margaritaville Beach Resort here on South Padre Island. And then you can see the roadblock. That's the one in the middle on the right. And then I'm not sure what is in the lower right. Is that just South Padre? That's our view from the roof.
That looks from the hotel.
Looking down at Isla Blanca Park. I think that's what that is. Yeah. South Padre Island, you can see. Is that the traffic? Is that the classic launch traffic?
Be really careful though on that traffic.
Yes, please be careful.
Yeah, there's a bridge and all that you have to cross, right? And so sometimes it can be a bit dangerous. Be very careful.
And everything that we did today, when SpaceX is ready to go again, we're going to do again. So we're going to be bringing you all the great coverage from the cameras and the folks in the field and the roof of the Margaritaville. But in the meantime, you can always check out Starbase Live, which is our 24-hour cameras that are remotely operated by some very, very talented folks in the control room that bring you that coverage with audio from Starbase 24 hours a day. If you want to see some Falcon 9 launches or other launches from the Cape, you can always check out Starbase Live. We have cameras of the drone ships coming in. We have of the port where they're reconditioning those Falcon 9 boosters. Also, several of the other launch pads, and of course, views from the press site there. Check out Space Coast Live. And if you're if you're really rocket nerd like us, and you want to see some cool engine tests from the stands at McGregor, you can check out McGregor Live as well. We have 3 24-hour live streams for you here on YouTube to check out. So, as we go forward, we're looking for how long SpaceX is going to take to recondition the tank farm, the issues. Maybe they're going to put out a tweet or something, or what do they call it, an X post now or whatever, to tell us what actually went through. So we will be able to bring you that information on all of our socials. It's funny. Every stream is a countdown to launch. Every launch is a static fire till the lifts off. Every static fire is a wet dress rehearsal until the engines are lit, and every wet dress rehearsal is an ambient test till prop load. What does that say? Probably load does full tilt. I don't know what that last line was. That was good, Carson. That was one of our engineers in the control room. Good stuff. Good stuff. EJ, you're going to be here with us tomorrow, yeah?
Oh, yeah. I'll be here.
Till the rocket launches.
Oh, yeah. Well, I'm here for the duration. It's going to be a good time, hopefully.
Yeah. We'll see what happens. I will be here. We've got Adrian will be here, obviously, and then Alex to answer all the questions. I have questions for you. Yeah. How many trucks do you think it's going to take to load the farm?
Yes. Probably yes. Probably yes. Yeah, I'm going to go with yes amount. Yes amount.
Yes. I'll go around the room here. Alex, how many tanker trucks are going to be going up and down Highway 4? Go.
Well, the last time we had a scrub, it was on Flight 1. That was many tank farm times ago. But yeah, you know what we can also do if there's a scrub? Adrian.
What? Go to Adrian.
What happens when there's a scrub? What we can do as well? You're muted.
Do you know there's a mute? There's a mute button apparently.
Yeah, right.
That's crazy.
What else we can do?
Apparently, so people have asked about some older designs we have, and we had a very iconic one back when Starship scrubs were, let's say, a bit more familiar, like common, and we are bringing back something here. If you click on that shop now button there's a certain shirt design that we are bringing back for the next 12 hours.
Oh,
well, this has happened. It's the eat, sleep, scrub, repeat. Because that's very much what could happen here. And yes, it's available in orange. I made it available in orange.
It's orange.
Because that will make Jack happy.
It's orange?
It is orange. So go to shop.nasaspace.com, now available. It's available for 12 hours and then only again after the next scrub.
There you go. Scrub merchandise on shop.nasasspaceflight.com. Thank you, Adrian, for putting that up. Look at that beautiful patch. Go get your patch as well. Have you ordered your patches yet, EJ?
Of course.
You're making the face. I ordered
what do you
two.
mean?
I ordered two. You're making the face.
I only ordered one.
He's
What do you think? What do you think? You only ordered two. I'm better than you, huh?
Yeah, you think? Okay, I know it is. He's making the face.
I'm not making the face.
Look at that, Adrian. Adrian's laughing at you because you're making the face. Look in the camera. Look in the camera. Tell everybody I got my patches.
I got my patches. I got them.
I ordered two. I got your patches. Alex,
Did you know?
Alex, why are you wearing a sweater? Is it cold where you are?
Well, it's actually not very cold, but this was sort of the first NSF merch that I had at hand. Unfortunately, this one has already been discontinued because it's from like 2 years ago.
Collector's
but yeah,
edition
this is
now.
Yeah, it's collector's edition, I guess. It's from Christmas 2023 or holidays 2023.
I gotta get my shirt.
Note to self: send Alex new merch so he doesn't wear Christmas sweaters in March.
Yeah.
Hey, I also hang on. Turn me off camera. I have an NSF shirt below, but it was too cold. Like it's that moment in the year that if you wear a simple shirt, it's like you're too cold, right? And if you wear a sweater, it's too hot. But I can manage with a sweater.
So I have a question actually. While you're doing that, we're seeing the views again of the roadblock, and we talk about they're not going to let anybody near that ship until it's completely detanked and safe, right? EJ, we'll bring you in on this one. Yep. They're going to hold them at that roadblock right near our river camera until the ship is completely detanked, safe. The areas they got to fly drones, they got to run the dog out there, sniff it. What are they going to do?
Yeah, basically, once they're gonna wait to detank, and what Alex is saying, that depends. It might take some time, might take more time, and then when it's fully detanked and the pad is safe, that's when the roadblock will go away. They'll release the roadblock, and then SpaceX can go about their business.
Well, it's not only SpaceX. We have to go about our business. They've got to go out there and get the cameras, refurbish the cameras, and get the batteries, all that stuff.
Don't remind me.
There's so much work that goes into this. And, there's so many people behind the scenes that you don't get to see in the control room, remotely operating the cameras, writing scripts, doing the overlays, doing the graphics. And if I started to list them all, I know I would forget them. I forgot Blue Sky about 15 times. We were talking about the socials, but if I started to list them, I would forget them all. So remember, it's not just us. There's a team of very dedicated rocket nerds like you that are working here at NSF. Good, Adrian.
I want to point out that you're totally not naming them right now, but imagine Kevin Michael Reed telling you with a 1 minute warning. By the way, Adrian, you will thank everybody after this launch. So
I was just
that's what he did. Not this. Kevin,
I don't know if you guys can hear me.
Yes,
Kevin.
We can.
You can. I was just about to say it is a tradition to thank
after
all of
launch.
the people behind the scenes.
Is this going to
Flight.
viewers, by the way? He's
This
talking
is
to
going
us.
to viewers.
Kevin,
Okay, so
Okay.
everybody can hear Kevin. That's just Kevin Michael Reed from our control room. Our
This is
Kevin-
all the time, by the way, in our ears. He's
The
just
voice
yapping.
in our ears.
It's like,
Yeah.
oh, we're going to cameras. We're going to show this. We're going to show that.
By the way-
Imagine having to commentate with this.
This is just a taste for those of you still viewing. This is just a taste of what it's like to be a Capcom or above member at NSF. All the behind the scenes stuff. Kevin is talking in our ears all during the stream, so now he gets to talk to you directly.
You're welcome.
So-
you love it.
You
do love it.
honestly, I'm not sure if this is a discussion for on stream, but I think there's a non-zero chance we are live again in 14 hours. I'm just saying.
Oof.
I'm just like I could like reactions in people's eyes there right now.
We're gonna have
but-
Jing and EJ on that stakeout stream, by the way. If we go in tomorrow,
Ooh, I
they're
don't know
gonna go.
about that.
The first ones, they're gonna be.
I think I remember what Kevin was talking about. He's talking about Adrian speed running all the thank yous.
No,
I forgot.
not today.
I
After
remembered. I just remembered.
after
Only
the
after
launch
successful
tomorrow
launch.
or Wednesday, I will do it, but not today.
Yeah.
By the way,
Yeah.
we can give a little sneak peek. Ready? Just Membies
go.
behind the scenes.
Ooh,
Wow.
look at that.
This
Look
is,
at that.
This is what
Oh,
it
he's got
looks
the
like.
goods.
It's,
Yeah.
Everybody wave. Yep, you're right.
Everybody wave.
Thanks, guys. You're awesome. I totally forgot we could wave.
This is for all the
So-
people that stuck around for this
Yeah.
live stream
This-
because
see all the people-
there's a
all the
lot of
people-
people. Yeah, there's a bunch of people that see scrap and then they leave and then they miss all of these interesting back and forth. Anyways, continue.
This may be the most cameras we have deployed for a Starship stream, and there are 37 cameras dedicated for live on this, in addition to all the recorded cameras and remotely operated still
I see a
cameras.
Gage.
And
Hi, Gage.
yes, there's Gage. But if you are a member, you can tune in to the Membies behind the scenes and see that,
Oh, you can see my green screen. Ooh.
and listen to me.
Oh yeah.
You get
Let's
to
go
see
back
everything.
to
It's not PG
back to
though.
the studios.
What is that? Oh, that was the behind the scenes. There's so many cameras. There's cameras everywhere. Guys, it's been a lot of fun. Yeah, I know we don't like scrubs. We don't like scrubs, but they happen. But it's a privilege for us to do what we do. Right, EJ?
Oh yeah, it's absolutely a privilege being on here. It's a good time, and the community over on YouTube and then my community back on the Twitch channel, twitch.tv/EJ_SA, have been really good to us today, supporting us and doing all this cool stuff. Also, happy birthday, Mom.
Happy birthday.
She
That's
let me.
right.
She
Happy
let me stay
birthday.
down here.
You're a legend.
I had to.
You're a legend.
I had to. Happy birthday, Mom.
Yeah.
You rock. I love you.
I'm going to go around the horn just real quick. I'll be asking questions. Don't forget, we had people everywhere. We didn't get a chance to thank them all, but the one and only DOS was on the roof all day in the clouds, trying to get the cameras up, getting rained on. Also, Gage was up there on the roof with him as well. So hopefully the next time we do this, turn that around. The next time we do this, we'll be able to talk to them and look at cameras, and he's going to just show you. Go ahead. Go full screen on hotel. So you can go ahead, stay out there. They can see you. You just lugged that down. Okay, go that way. Yeah, there's DOS. There's the camera.
Hi,
What did
Daz.
it get up there?
Oh, sorry. I have
Is-
to jump in here.
Go ahead, Adrian. Go
I have
ahead.
to. We have an update from Elon Musk.
Mm-hmm.
Too many question marks about this
Oh.
flight, and then we were 20 bar low on ground spin start pressure. Best to destack, inspect both stages, and try again in a day or two.
Whoa.
Oh dear. So this stack.
So they are going to destack, and they are going to inspect both of the ships, which, again, I would rather have a 100% healthy ship on launch than a 95% healthy ship in orbit. So it is going to be a couple of days. Again, stay with us. All of our socials. Stay on Starbase Live, and you'll see all of the
Do
destack.
we-
Now, go ahead.
Do we want to sort of, take apart those updates, those words that Elon mentioned, maybe for the people
ahead.
that don't?
Yeah, go ahead.
Yeah. So, when he refers to the ground spin start pressure, so he's referring to the system on the ground that starts the engines on the booster, right? Ground spin start pressure. It's usually a really high pressure system, right? So that's why it's 20 bar. Just for reference, that's like 20 atmospheres, I guess,
20
of
atmospheres.
pressure. Yeah, so that's a lot of difference. But that system given that the pressure on the pumps it's really high, it's a small difference compared to that, but it's enough for them to say, okay, that's not what we want. We'll take a look at it, and then we're gonna be going again for a launch. And so that's the system that that he's talking about, the ground spin start system, and. So best to destack, inspect both stages, try again in a day or two. We'll see whether it's a day or two, right? That's now the main question. Will it be a day? Will it be 2 days? One of the big issues right now that I think could be for a day, right? For the case of a day, is that destacking now needs to happen after they have already saved everything. Then they need to clear the pad. Then they need to go out there, look at the two vehicles and everything. So a day, more of the two of the other that he's mentioning, right? That other option. But we'll see.
Well, they have until Thursday, so they've got tomorrow, Wednesday, Thursday. And we'll see what happens. You're in the same boat with us. We are watching this happen and unfold right in front of our eyes. And again, we'll bring you all the information as we get it. But that's it's good to know that the sensors worked. As I keep saying, this is all testing. The sensors worked as expected. So again, we will bring you information as we get it. What? Oh, the conversions of bar to PSI. That's what he's talking about. But 20 bar is, what did he say? I can't remember.
It's 20 times 15, give or take.
We've got people doing math in our ears and talking to us right now.
Yeah,
right,
that's the difference. 20 bar is 290 psi, pound per square inch. But the total, this is the problem that the ones that I heard, at least for some other engines, it's right in the order of like 6,000 psi for the pressure in pound per square inch, which in bar it's about 410, 420 bar. So it's not a huge difference, but it's still the total amount of pressure that they need to start those engines. Can
I just point out that Alex was saying it's so late here, we got to go, and now he's doing math.
Go,
hyped up over PSI.
Wrap up.
No, you keep talking about
if Alex wants to continue talking about this, I'm looking forward to the impromptu Raptor site that he will perform.
Oh dear.
48 hours. What's the world record for a Raptor side? And go. Guys, thank you so much for joining us. We are going to wrap it up here from the Margaritaville in South Padre Island in Starbase, Texas. For EJ, for Adrian, for Alex, for Kevin, and everybody in the background, I'm Gene Rowley. I've been your host today, along with my friend EJ. We will catch you on the next one. Remember, dream big, keep your eye on the stars.
And here we go.
We have liftoff.
Propulsion continues to be nominal.
RCPA chamber pressure looks good.
Traveling up. Roger, planet.
Water towers, fly! Payload down to nominal.
Flighting downside SPD off. Bring in SPD off. It's orange! Orange 45! Oh my god! Oh my god! Decollage! What is it? Put that in the big bag,
343 unfolds to go.
Indeed.
We rise together back to the moon and beyond.